I'm showing exactly 120, so I'm going to start. Are you guys ready with AV? All right. Stuart, are you going to lock the door in the back so nobody can get out? Okay, good. Okay. Welcome everyone to the Python 3 metaprogramming tutorial. Quick question: how many of you are using Python 3? Yeah, the number's going up. Okay, we're up to like 10% of the room now. Okay. What's this tutorial about? First of all, this tutorial is Python 3.3 or newer. If you're using anything else, you're living in the past. It's dead to me. I'm not talking about that. Okay. There are some support files. If you go to the website, you are not going to need those for this tutorial unless you want to try and follow along. This is going to go pretty fast. So unless you're like a super fast typist or anything like that, it's not the kind of thing where I'm just going to have you do a bunch of hands-on work. It's going to be more live coding and some other things. Basically, the gist of this tutorial: 2 advanced topics, Python 3, metaprogramming. Can you have too much of either? Answer is no, as you will see. If you're new to metaprogramming, it's, in a nutshell, it's basically code that manipulates code. It's things like decorators, it's metaclasses, descriptors, things like that. If you've ever seen this stuff before or heard about it, it's manipulating code in your program. And why you would care about this is basically the magic that a lot of, I would say, advanced frameworks and libraries use. They use a lot of this stuff to do interesting things. If you understand it, you actually get a much deeper understanding of how Python works. Generally, I think it's sort of fun and evil in a sort of interesting way, and it actually solves sort of a practical problem, which is basically dry, which is don't repeat yourself. As I'm illustrating here, not repeating yourself. Basically, highly repetitive code really sucks. It seems like if you have code where you're like constantly cutting and pasting and things, it gets really tedious to write. It's hard to read. It basically, what ends up happening is it just motivates people to write tools to automate the process, and then the tool becomes this like own monster of itself. So repetitive code, sort of not very fun, and that's actually what a lot of metaprogramming gets into, is sort of automating repetitive tasks. So what we're going to try to do in the tutorial is kind of a modern journey of some of this metaprogramming stuff. If you haven't done much with Python 3, it seems like everybody focuses on Python 3. They're talking about, Unicode. It's like, oh yeah, okay. First of all, there's not going to be any Unicode in this tutorial. Okay, so, and honestly, I think Unicode is probably the least interesting part of Python 3. I mean, it's there, but it's just sort of boring. I mean, nobody cares about that. I mean, okay, so the really interesting part of Python 3 is more actually in sort of the language itself, some of the metaprogramming features, some of the advanced stuff. So I'm going to try to get into that. I'd say the target audience of this talk is basically framework library builders, or just anyone who wants to understand how that stuff works. I think it's kind of fun to look at how it works. As far as some reading, little shameless self-promotion, the contents of this are sort of loosely based on things in the Python cookbook, 3rd edition. This is the mythical 3rd edition of the cookbook, which actually is in physical form, fully written at this time. It's basically going to press in May, so right now it's in copy edit. If you want to take a look at this, by the way, I'm going to have it kind of floating around the conference and stuff. So that's actually coming out. And one little caution: if you do everything in this class or tutorial all at once, you'll either be fired or have permanent job security. That's all I'm going to say. It's a fine line between the two, as you will see. And so let's just do some preliminaries. One other thing. The whole tutorial, I don't know whether you can see that very well, has sort of a theme related to the movie Apocalypse Now, which is one of my favorite movies, actually. It's a sort of, the journey up the river, and it gets more and more insane the further it goes. So it's gonna kind of have that theme to it here. So let's do some preliminaries. There's some stuff that you should know up front, and I'll apologize if this is going to go way fast, but I have to go through this pretty fast to get to the interesting stuff. As you know, code is basically built out of some basic blocks: statements, functions, classes. And statements obviously do the work of your program. You can execute statements using the exec function, which we'll see later, but basically statements execute your program. Functions are probably the unit of most code in your program. You write functions and modules, you make methods of classes and so forth. Just a bunch of statements with a name attached to it. With functions, you should know about that there's two different calling conventions. You should know about positional arguments, and you should know keyword arguments. You should also know that you can have default arguments. Hopefully you know that defaults are set once at definition time, and generally it's a bad idea to use mutable values for that. I don't really want to get into that, but generally you don't want to use things like lists and dictionaries as default. You should also know about star and star args, star args, star args. This is basically a way of collecting positional and keyword arguments into a function. Basically call a function, all the things passed by position go into args. Everything by keyword goes into keyword args. And you should also know that you can pass tuples and dictionaries doing similar convention. So if you have like a tuple, you can pass that as arguments using the star. Same thing for a dictionary. One Python 3 thing that we're going to use a little bit is Python 3 has this keyword-only argument style. This is not available in 2, but if you write a function and you put a star and then you name more parameters after the star, it turns out that you can only pass those in as keywords. There's some interesting techniques that you can do with those, by the way. Like one of the things you can do is add keyword arguments to functions that take any number of positional arguments. There's some, interesting sort of techniques there. Another thing that I hope you've seen is the concept of a closure. If you have not seen that, basically the gist of it is you can write a function that makes a new function. Code generator. Think of it as a code generator. So you can say, oh, like make adder, here's define a function, return it back. That thing that returns back is something that will execute the code. You're like making code. We're going to use that a fair amount. And then you should know some things about classes, basically simple class definitions. Just some terminology here. If you have a class, any kind of variable that's defined at the class level is something known as a class variable. Any variable that's defined in the init function is an instance variable, and any kind of method on there is an instance method. A little bit of terminology. And you might also want to know about some of the other method types as well. There are basically class methods that are executed on the class. Just a little bit of subtlety here. An instance method, you execute that on an instance. Class method, you execute it on the class. Static method is just a function put in a class, basically. Okay, so those are some things that you should know. Also, special methods. You can customize almost every part of Python using some kind of special method like getItem or getAttribute and so forth. And then inheritance with classes. You can basically take a class, inherit from it, and then customize it. Make some changes to it. And then last but not least, I hope that you know that the Python object system is layered heavily on top of dictionaries. Okay, so when you make an instance, that's essentially a dictionary sitting underneath the covers, and you're manipulating that. So that is the basics that I hope you know coming in here. If not, I'll just have to apologize for what's going to come. So the first thing that we're going to do here is I want to illustrate some basic metaprogramming concepts with something that is very, very easy before we get into like the really insane part of it later on. So the thing that I'm going to look at first is just the problem of debugging, mainly because it's really simple. So if you want to do debugging, the only proper way to do it is with the print statement. Okay, that's what I'm just going to say that up front. You have to use the print statement. That's the only one and true way to debug. So you have a function, put a print statement in there. Works great. You just run. You don't have to recompile or anything. Just run it, get print. Problem with that is it gets kind of repetitive after a while. I mean, if you're really having a problem, you're going to start getting a lot of print statements on functions and so forth. So you see something like that, and it's like, okay, sucks. Okay, so what have we got here? We have code repetition, repetitive code, repeating myself here. This is basically where you start to introduce decorators, or it's one place where decorator function might come up. It's basically what a decorator is. It's a wrapper around an existing function. And generally what you're going to do is just take that original function and put like some extra code around it. So this is the kind of thing that you would do. Let's just do a little live demo here. So I'm going to make first of all metaprogramming, by the way, needs to be done in Emacs. It works better in Emacs. So, yeah. Well, it helped. It's because of the Lisp. It likes to be. It's sort of like homeopathy, right? It picks up it picks up the metaprogramming from the Lisp, even though we're not doing, let's not go there. Okay, so I'm going to make just a file here. I'm going to call it Debuggly. Everything in here is going to have an L after it, because that's, the thing to do these days. So basically what a decorator might be is it's basically a function that takes a function as input. Okay, so funct is like your input function. Well, what the hell does that? Okay. Can't even write a comment. Okay, so that's going to be wrapped. And then what you do is you just define a wrapper that typically takes all arguments, like this. You're going to put your print statement in there, like, I don't know, print. Python 3. Oh, Python 3, yeah. That print thing has got me so screwed up, man. It's like, so first of all, like when I first started doing Python 3, I started doing printf everywhere. I'd have like, no, it's true. I would write these programs and I'd go in there and run it, like 40 occurrences of printf coming from like, because I used to do a lot of C programming, and it's just, I don't know. So, okay, that's neither. Okay, print func name, and then you just return the function. Okay, so you would do something like this. Basically, you're making code here. Okay, so you're generating a wrapper, you're returning it back, and then what you would do if you wanted to apply that in your code is you would just say, okay, from debugly import debug, and then you would just apply it to your functions. Okay, so something like that. So if that worked, which I don't know, we'll find out if it did here, I should just be able to import that example code, do an add, 2, 3, and then print out the add message there. Okay, kind of lame there, but that's sort of the idea with a decorator. Basically, taking like an existing function, you're going to wrap some stuff around it. Now there are some technicalities with decorators that are a little bit unfortunate. One of the things that's a little bit nasty about them, and you may know this already, is that they tend to lose a lot of their information. Like they lose their name. Like here it comes up and just says function wrapper, it's like, okay. And the other thing is it tends to lose like help information. Like if you do a help on it, it just sort of, wrap is like, what in the world is that all about? So one technicality with some of these decorators is that you have to do some other things. To really write them properly, you have to import this wraps feature from funct tools and then apply that as a decorator to funct. Okay, so you have to use decorators like in the implementation of a decorator. It turns out that what that does is it copies metadata from one function to the other. It changes the name, it copies documentation strings, does some other things. So that's kind of like a basic decorator. You can do that. Oh, actually, one note. I didn't do this in the example, but functions in Python 3 actually have this new attribute qual name that you can use instead of underscore name. It's like actually the fully qualified function name with like the dot of where it's located and so forth. So actually, let's see what happens if we change that. If you notice here, it sort of did it just printed out add. So let's try that again here. Well, it still printed out add. That qual name thing will actually come into play if you start using it with classes and stuff. It will actually print out like the class name along with the method. So that's some simple decorator stuff. I'm actually kind of hoping that you've seen simple decorators before coming in here. So
this qual name, it's just goes up to the class. It's not like modified, right?
Yeah, the qual name. Yeah, questions about the qual name. I think it uses it will start with the class name and then give you the dotted thing. Yeah. Yeah. All right. So that's a basic decorator. Now, yeah, and I mentioned if you don't use that wraps thing, weird things happen. So generally want to use that. And then, okay, so slides kind of go through this demo that I just did here. Big picture. One feature about using a decorator is that you actually isolate the debugging code to a single location. I mean, this is actually one of the benefits of doing this decoration stuff, is that you can just apply that decorator a whole bunch of things, and you don't actually have to care about the implementation details of the decorator. I mean, this is the benefit of it, is you just use it, And then if you want to, you can actually mess around with the implementation of that debug. There's all sorts of things that you could do in there. You could change it to use the logging module if you wanted to. Okay, so there's a variant there where it's just like, oh, okay, let's use logging and send data out to logging module. You could do things like have optionally disable the debugging. I don't know, maybe through an environment variable or some other thing. Key idea though is that you can change the decorator independently of the code that's using it. Do all sorts of different things. Very, very kind of cool. Now some variations of this. Let's go back to the debugging with print. It turns out if you debug with print, you're not doing it right unless you include some kind of magic prefix on the output. Okay, so like triple star or plus 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 or one or bracket or something, because basically you have to grep through the 50 megabytes of output that you get from your program, and you have to see your debugging messages. So one of the things that you might want to do is have a decorator that takes arguments as input. Like maybe you want to change this so you can say, well, I want to debug it, but I want to pass in like a prefix or something to make that work. To do decorators with arguments, it looks a little bit weird due to the calling convention that takes place. Essentially what happens is you take a decorator, well, it basically calls the function with the arguments, and then it takes the result of that and calls it with the function. You end up with this really sort of bizarre construct here, essentially two levels of nested functions. And if you haven't seen this before, here's the gist of the idea. Basically, the outer function provides like an environment for use in the inner functions. Okay, so what happens here is this outer function takes like an input value prefix, and then that variable is just available inside that whole block of code. It's just sort of saying, okay, here's this argument. And then what you can do inside is you just write a normal decorator function, except that you can refer to that variable that got passed in. It looks a little bit funky if you haven't seen that before, but it's basically just this outer function that passes that in. There's an interesting reformulation of that I sometimes will do. See if this makes any sense here. Sometimes I'll start. Maybe I'll do this as a demo. It turns out that if you want to add an argument to a decorator, it becomes sort of weird because you have the prefix that you're going to pass in, but then you end up having to write sort of the same code that you had before. This is what you would have to do normally. It's like you would sort of start writing the code like this, and it's like, okay, I'm getting code repetition inside my decorator, which is supposed to eliminate code repetition, right? It's like it's messing with my brain that I'm repeating code here. So you can actually do some little tricks here. I mean, one trick that you can do is play some games with optional arguments. Like this. Let's see if you can figure this one out. Okay, so I'm going to make a function where everything is optional. The funct is none, prefix is that. And then I'm going to check if the function is none. It means that it wasn't passed, okay? And I'm going to do this sort of hack like that. You're like, good God, what in the world is that about? So the idea here is that if the function was none, this thing calls itself again and returns it, or it uses this partial function to sort of return like a callable that will invoke itself again with the data. The way that that's supposed to work is you would go into your example code, like, actually let me use the prefix here. Okay, so I'm going to make a message and use that. The way that would actually be used in your code is really like this. You could either use it as debug, in which case it would work normally, or you could come in here and specify a prefix. You just say, oh, the prefix is star, star, star. It's kind of like a decorator that works either with an argument or without an argument. If it works correctly, which I don't know whether it will, but we'll find out. Okay, there's the add. There's the star, okay, the sub there. It's basically taking that as an optional argument. And again, you probably maybe have seen that before if you've done decorators before, but it's sort of an optional version of that. So that's how that's going to be used. Now, just to move on from that, here's sort of the next level of some of this decorator stuff. Let's say you wanted to debug all the methods of a class. Okay, you have a class and you're like, I want to apply a decorator to all the methods. One of the things that somebody might ask is, can you just automate that to do all the methods at once? This sort of takes you into basically the area of what's known as a class decorator. Turns out you can apply a decorator to a class definition and do something like this. You can basically say, hey, I want to debug all the methods of this class, and I'm just going to walk through the class body and apply decorators. Now, how that actually works, let's do a little demo of that. What you can do here is you can say, okay, I want to write a function where you can say debug methods, where you're going to hand me a class definition. Okay, so CLS is a class. And what I'm going to do is walk through basically the dictionary of that class. Okay, so what I'm going to do here is I'm just going to say, okay, walk through key value. Vars, by the way, will give you the class dictionary. So I'm just going to walk through the class dictionary there, saying, okay, well, let's just see everything that you have in there. And then if the value part of that happens to be callable, I'm just going to rewrite the class. So I'm just going to set adder on the class key debug of val. That's what that's doing. It's basically walking through the class and then it's like doing brain surgery on it. It's probably a really bad idea, but that's what's happening there. So you have this function sort of walking through the class definition, putting a decorator around everything, returning the class back. If you've done that right, you should be able to write a sort of a class definition like this. You could say at debug methods class span. I'm just going to put few methods on there like that. I also need to change the import to do that. So. Okay, so if you do that, you should be able to make like a spam object. Oh, import. Okay. Trying to go fast here. Okay, so there you see basically it comes out and says spam.a. That's actually the effect of that qual name, by the way, is that you get the full class name and the name of the function in there. Okay, so this is sort of taking it to the next level. Basically, you can say, okay, I've got debug methods, takes a whole class definition, just decorates the whole thing. Okay, so kind of building up some concepts here. Sample use of that. There are some limitations of that I'm not going to get into right now. It does not work with class methods and static methods. So I'll leave that as an exercise for the reader to figure out why. So it's some advanced stuff there. But then, there's what?
Does it work with other decorated methods?
It probably would work with other decorators, just not those. It might work with those if you did it in the right order. Well, actually, no, I don't know. No, it's not going to work with those, period, in the way that we've got it set up.
Yeah. Well, let's say, you have some other decorator.
Yeah, it would probably do it. You could experiment with that, like.
Which gets decorated first.
Yeah, you could do something like let's say you had something like this. Yeah. It probably would work with that. I mean, what would end up happening is you'd get double output.
Yeah, but what order?
Yeah, what order? That's a good question, actually. I think the class method would come first because that was the outermost wrapping, and then the other one would come next there.
What are the methods defined before the class itself? The actual building of the class?
Yeah, the methods would get defined first. Yeah, and then the class decorator would come in after the fact. Yeah. Okay. All right. So you can do that. Again, moving pretty fast here, but you'll see why in a second here. Okay. So, some other interesting stuff with class decorators, by the way. I mean, this is sort of a sneaky thing too. Class decorators are actually cool because you can do all sorts of horrible, like, brain surgery on classes. This is actually kind of an interesting one that is debugging attribute access. And the concept here, I'll sort of just talk through it, is that you give it a class, and it reaches into the class and just yanks off the get attribute method. If you don't know what get attribute is, it's the method that does attribute lookup. So you're just reaching in, you're like yanking it off. And then what you're doing is you're writing a replacement for it that has a print statement, and then it calls the original. That's what's going on here. It's sort of saying, well, okay, just print it on, then call the original version. And then what you can do is just drop this new version on the class. You can just say, here you go, here's your new get attribute method. Return it back. What would happen with that is if you put this in front of a class, all of a sudden you'd start getting messages for all the attribute lookup. You've done some sort of evil, patching or hacking of the code there. So there's a variety of sort of interesting things you can do with that. And then kind of the final frontier here. What if you wanted to debug all the classes? I mean, I don't know. At this point, you might just say, well, you don't know how to program if you're doing this, right? You got to put a print statement on every method of every class and like some hierarchy or something like that. Again, you get back to this repetitive code business. If you want to solve that, the obvious solution is to define a metaclass. Okay, so you're like, what in the world? I'm going to talk about this in a second, but what?
For what value of obvious?
Yeah, what value? It's obviously a metaclass. Let me talk about this for a second. Well, let me tell you what this does, and I'll get into the details in a second here. The idea here is that this basically creates a class normally, and then it comes in and applies a class decorator to it. So what it's doing is it's saying, okay, make a class, now automatically wrap it, return it back. Okay, so a little bit of a head explosion with that. If you have not done anything with metaclasses before, here's the gist of the idea. Every single value in Python has a type. Hopefully this is something that you know by now, but like an integer has type int, and a string has type str, and a list has type list, and so forth. Everything has a type. There's a type system. It's in the language. Every type in Python is defined by a class. Okay, so there's a class for ints and a class for lists, and if you make your own class spam, and you make an instance of that, and you ask, what's the type of that? Python will say, it's a spam. Okay, the type of it is a spam. So classes are defining types. Very important part of the system. Now, here is where things get a little bit weird. Actually, I have a little bit of a typo in the slide here. I'm actually noticing this. Basically, the types of classes are all instances of types. Now here's the typo. Let me just fix the typo. This should actually be coming back telling me that it's a type. Okay? Not enough coffee when I prepared this, apparently. Okay, so it turns out that if you do this, everything will come back and tell you that it's a type. Like the type of int, oh, that's a type. The type of list is a type. Type of spam is a type. Everything is a type. And you have to think about this. Like, okay, classes are instances of types. Instances of types. Okay, well, if it's an instance of a type, then type must be a class somewhere, because that's what classes make instances. And it turns out that there is a class type. And what does a class type make? It makes instances of types, just like a class spam makes instances of spam, or a class int makes instances of ints. So there is this type object that makes instances of types, and it turns out that this is what makes classes in Python. So let's say you had a class spam, base, init, bar, something like that. If I were to ask you to deconstruct this thing, it's like, what is that? Well, it has a name, which is spam, and has a base class, which is base, and it has two functions that are in there, init and bar. It turns out that if you take all those components, this is sort of what happens when you define a class. It turns out that class definitions, basically the execution model, is that the body of the class gets isolated. Okay, so the statements that are in the class kind of get pulled off, isolated. And then what happens is the interpreter will go off and make a dictionary that serves as the class namespace. Now, this is actually something very new that we're going to come back to later, but to do this, there's a method on type called _prepare that makes the class definition. Basically, it goes to that and says, okay, make the class dictionary. Okay, so usually it's just usually a dictionary. Then what's going to happen is the body of the class just gets executed in that dictionary. It's basically just run all the statements in the class, in the dictionary. And what will happen is that dictionary will just get populated by doing that. It'll get populated with all the methods. And then you just sort of throw this thing to the type class. You say, hey, go make a type. There's the type, it's spam, base, there's the dictionary, and then voila, you have a class. You get a class definition out of that. So essentially this type is making a class. And here's the sort of the idea on the metaclass stuff. What if you wanted to use something other than type? Like you want to make a totally different kind of type at that last step. Turns out that you can specify this when you do a class definition by just saying, hey, the metaclass of this thing is type or something else. Turns out that whatever you put here is what is going to get used to make the type when you're done with it. So one of the things that you can do is start making your own sort of customized types, if you will. I mean, what you can do is you could do something. Well, here's sort of a whimsical example. We'll do it interactively. You could say, okay, I'm going to make my type inherit from type, and then I'm going to put this new method on here. Basically, what you get as input is the class name, the bases, and the class dictionary. And what happens is you're just presented with all this information. You're just saying, okay, here's a class that's being made with class name, bases, and dictionary. You can do anything you want in there. Like one of the things that you could do is you could say, well, if the number of base classes is greater than 1, raise type error, no, or something. Okay, so so you could do something, do something like that. Okay, new. I'm hoping that this will work here. Okay, so one other thing about Python 3, by the way, you don't need to supply arguments to the super function anymore. So I use that a lot. So what would happen there is you could just say, well, okay, here's some class base. Metaclass is equal to my type. And okay, you've made a class. If you started using this, like let's make a bunch of classes here. It turns out that code, if I've done this right, is actually working behind the scenes. And if I were to make a class that inherited from like 2 different classes here, let's see what happens. Type error, no. Okay, basically it's being processed by that code. And the way that that's working is you've sort of made like a custom kind of class object. This is kind of the idea in some of this metaclass stuff. Yeah. The question is, do metaclasses have to inherit from type? Honestly, I don't know for certain, but I've never had one work without it. So I would say probably yes, like a 95% sort of qualified yes. But you definitely will. You'll generally do something like that. And really, the key thing with a metaclass is that you just get all of this information about the class. You can inspect it. You can modify it. It's kind of like a class decorator. And in fact, many of the problems that you could do with a metaclass, you could do with a class decorator. So, which actually raises the question of why would you do this instead of using a decorator? But
so since type runs the eval on the code, the exact code in the body, and you use something else, like a C compiler. Does Python actually flex that code out before it does anything, or?
Yeah, the question is, I guess, about code in the class body. I mean, I know Python will execute any statement whatsoever you put in a class body.
Right.
Like if you put print statements or anything, it literally runs the class body just like a script. So.
But with the metaclass?
Yep.
So it does that first.
It does that first, and yeah.
Okay.
Yep.
So you can't quite hold that and
Yeah, basically, the question about the execution of the body, I mean, it just literally executes that. Whatever's in there, yeah. Regardless. Now, one of the questions that comes up is like, why would you use this metaclass stuff? I mean, actually, if in the Python world, metaclasses kind of have I don't know whether they have a bad reputation, but they sort of have a reputation of being sort of insane, or the Python's killer joke in reference to the Monty Python skit, where if you hear the joke, you die instantly, sort of thing like that. Really, probably the key thing with metaclasses is that they propagate through inheritance. This would be probably the distinguishing feature, is that if you put a metaclass into a class hierarchy, it actually becomes like a genetic mutation on the whole hierarchy of classes. I mean, it goes into the parent, and then it just propagates to all children automatically. And so somebody who's sort of suitably diabolical or something like that could drop one of these things up in like a base class for some framework, and then it just propagates everywhere in the framework. So getting back to what I did in the solution, we made a metaclass debug meta, that what this thing is doing is making a class and then it's slapping a class decorator around it. And it turns out that there's not much code there, but what it's actually doing is making that class decorator propagate through inheritance. That's really all that's going on. And it turns out that if you wanted to debug the universe, you just set it once in the base class, and then it just goes everywhere. Okay, so kind of a big picture on this stuff. A lot of this decorator or metaprogramming stuff, just if you were going to think about like sort of a theme here, it's really about wrapping stuff. Decorators, you're talking about wrapping functions. If you're talking about class decorators, you're talking about wrapping classes. If you're talking about metaclasses, you're really talking about doing things with class hierarchies. Keep in mind that there's this distinct, like a class decorator would be something applied to a single class, where a metaclass is like, we're talking about the whole hierarchy of code, changing the DNA of how things work. So, a little bit of an interlude here. Let me just pause for a second and see how people are doing before we go into the insane part of the journey here. Question from Mike in the back.
Metaclass you can get into the new. With a decorator you get an instance of the class, or you are later with the class.
Oh yeah. So Mike points out it's the order in which things happen is different. I mean, with a metaclass you can actually capture things about the class before it ever gets created. Where a class decorator, it's strictly after the fact. Like when you write a class decorator, the class has already been fully formed, and you're just looking at it afterwards. So there are some subtle distinctions there. All right, now question in the back.
When do you override under init versus under new?
Yeah, because the question is, when would you do new versus underscore init? You might need to do new if you want to change. There are certain things that you might have to put into a class dictionary to affect like how the class gets created. Maybe one example of that might be something like the slots attribute. I mean, that would be one example of that. I don't really talk about slots here, but there's certain things that you might have to put in a class definition prior to calling type to get it to create properly. Is that what you were going to point out, Mike?
You use init for this, init. But as soon as you slots, that's the only application I found. Slots, you have to have a new. Everything else pretty much you can do with init.
Okay, yeah. Mike sort of points out most of the time you can do things with. Okay. Yeah, I think for the most part, probably new and init, almost interchangeable. I'm sort of in the habit of doing new. Maybe there's no good reason for it, but it's, that you can sort of go either way with that. All right, so a little bit of an interlude here. Okay. This stuff that we just did is actually pretty well-trodden territory in the Python 2 world, okay? I mean, this, people are doing all of that stuff right now in Python 2. Class decorators and metaclasses and decorators with arguments and all sorts of things like that. I don't think, well, at least I hope not, you didn't come to this tutorial just for me to rehash Python 2 decorator. Okay, so I want to talk about some other things that are possible, some more advanced stuff that is Python 3 specific. And to do this, I'm gonna talk about a problem. We're gonna build something up from this. Let's say you had some code with a bunch of data structures, and this is gonna be something really simple. I actually have this code available here, so let me pull it up. Okay, so This is going to be my starting code like that. Does anybody sort of find that kind of annoying? Yeah, it's super annoying. I mean, it's like, oh, man, it's pretty repetitive. I've actually written code like this myself where I had to like define like 20 different data structures, all with sort of slightly different attributes. It's just like, oh, that's really horrible. So there's some things you can do with this. One of the things that you might see, and this is actually a technique used in the standard library, is you can just generalize this a little bit into with a base class. I mean, this is going to look like a little bit of a hack, but you can do things like, okay, I'm going to make like a structure class where you define like a list that has the fields. You'll see how this works in a second here. And then what I'll do is I'll just say, well, for name, val, and zip, self, fields, args, set attr, self, name, value, or something. Okay, so what this is doing is you're trying to write sort of like a generalized init function where you just say, okay, this is going to set a bunch of values. And then what you would do is you would define all of your classes to inherit from that. That's just a star args right now. But the idea is that you would, yeah. Okay, so you might do something like this. This is actually a trick I've used in Python 2 before to do this, where you would just say, okay, I need to put some base class. Okay, so what you do is you take a init, you hoist it up into a base class like that. Pert. Okay, good. And you turn your code into something like this. I'm actually a little curious. I mean, how many of you have seen this technique done before? A few people. Kind of the idea here is that you sort of start with that. Actually, I'm gonna write this to a file called I'm gonna call it structly here. Okay, so everything has to have an ly on it for this talk here. So this is going to be my structly file. What's going to happen with that, assuming I haven't made any mistakes, is that you could say, well, make a stock, goo 100 490.1 or something, and it would just go ahead and populate all the values there. It's essentially what's happening is you're sort of listing what the attribute names are, and then we're using the init function just to go through and set them. Okay, now so you had a question up in the front. Somebody had a question here, so.
I don't quite understand how fields gets into cells. You're setting it in a class?
Well, it turns out that class variables are accessible through the instance. Like you can say self.fields and it will go through the instance. It will pick it up. That's actually a very weird thing about Python, by the way. I don't know whether people have thought about that, but the fact that you can access a class variable through an instance is a little weird. I mean, it's a little weird in terms of OO programming sort of style. But I guess you could do this another way too. I mean, you could. Here would be the other way of doing that. Instead of going self_fields, you could chase the class attribute and do it like that too. So there's a couple of options there. Actually, that might make it a little bit more explicit about what's going on there. So I'll go ahead and leave that. All right, so you might do some trick like that. Now, does anybody see any downsides to doing that? Well, I didn't hear the comment, but one problem with this is that you lose a lot of like useful debugging kinds of stuff. Like one of the things, if you tried to do a help on the class, you don't really get any information about the calling signature. It's like just star args. You could, if you don't call it with the the right number of arguments, it's like, okay, that's kind of weird. It did s and it did name and shares, but then it didn't do price. So I got to okay, I got to add some extra checking to it. Another problem with it is you don't get keyword arguments. So you've like lost all of the ability to do keywords. So that basically doesn't work. There's a whole bunch of stuff that you lose by doing that trick. So what you've done is you've done like a bunch of convenience, but you've sort of messed it up for yourself. I mean, basically no support for keyword arguments. There's no argument signature on it or anything. Actually, one thing about argument signatures, by the way, I'm going to get into this. There's a new feature in the inspect module that will tell you the signature of things. This is this new signature feature. You can basically say inspect.signature on anything, and it will tell you the calling signature of it. You can actually look at it and pull information out of it and do different things with it. We're going to do some more with signatures in a second here. So this is a little bit of a problem. It's like, okay, no support for keyword arguments and other things. So I want to talk about signatures. This is a new Python 3 feature that got added here. Okay, putting the signature on things that only showed up in Python 3. And so let me do a demo. It turns out that in Python 3, you can actually construct function signature objects yourself. Okay, so here's sort of an interesting thing that you can do. I'm going to do this interactive. You can say from inspect, import parameter and signature. And what you can do is you could take like a list of fields. So let's say you had a fields list like name, shares, price. You could actually come in here and make like a parameter list. So you could say, okay, let's make a bunch of parameters by basically, I do a list comprehension here, just saying, okay, I want to make a parameter where this is sort of the field name, F name, and then it's going to look a little bit funny, but it's sort of like an enum or something. You're basically saying, okay, I want to make a parameter that's either positional or keyword. I hope I've done that right. Okay, so you're going to do something like that. This is essentially going to make like a bunch of function parameters. And then what you can do is you can make a signature out of that. You can just say, well, let's make a signature out of all those parameters. Okay, so you get a signature object. If you print it out, it will sort of tell you the signature on there. And you're saying, okay, that's kind of interesting. Now the question that comes up is like, what in the world could you do with that? Well, it turns out that with these signature arguments, here's the cool thing that you can do. You can actually bind them to star args and star keyword args. It's kind of a neat little trick. So one of the things that you could do is you could say, okay, let's just try that here. You could basically make a function like foo star args star keyword args. And what I'm going to do is I'm going to do like a binding operation like this. I'm going to say take that signature and bind it to the values there, and then what you can do is you can sort of pull the values off. I'm hoping that this will work here. So let's just try this here. So what's going to happen is okay. So foo 1 2 3. It basically comes in and says, okay, name was 1, shares was 2. Price was 3. Turns out that this binding thing is really smart about what it does. Supports keyword arguments. Get things in the right order. It will do argument checking, saying that it's lacking, basically lacking a default value. Didn't get a value for price. It will do all the error checking that you would normally do for a function. It's basically taking a signature and it's enforcing it on star args, star keyword args. Hopefully you sort of see that going on. That is actually kind of a neat feature because you can use that. Okay, so it does all the error handling, all the enforcement of stuff. You can actually use that in some of this structure code. Now this is going to look a little bit nasty, but what you could do is basically write a little utility function where you'd say, okay, make a signature on it, and then modify the init function to enforce the signature. So you could take this code and basically do that. So let me bring in some code here. I'm really fast at typing, by the way. I'm going to prepare that in advance. So what I'm doing here is I'm basically saying, okay, let's do a make signature. I'm going to modify the structure class so that it looks for signatures instead, and then does the init from that. What's going to happen to sort of make that work is now all the classes are basically going to do something like this, where they're going to say, okay, signature is equal to make signature on the fields. So it's going to look a little different than before. Okay, I'm just going to do the 2 there. Okay, so let's just do that. But what will happen there is that all of a sudden your classes are just going to behave so much nicer. I mean, essentially, if that works, you'll be able to make, classes using any combination of keyword arguments, positional arguments, things like that. So you could, do, keywords and so forth, and it just sort of works. And it has error checking built into it too. So if you don't pass in enough arguments, it fails and so forth. In fact, even if you print out the signature of stock, it comes up and says, oh, it's name, shares, price. Very minor little thing, but it's kind of cool though. I mean, it's like you're providing a little bit more information to the user. It's actually simplifying quite a bit of code that you would have to write normally. I don't know whether anybody has ever tried to do that. If you've ever tried to write code that takes star args and star keyword args and enforce like a calling convention on it, it's actually pretty ugly. I mean, you're kind of nodding your head up here. I mean, it's really ugly. I mean, you have to check for all sorts of duplicates. Like, was it duplicated as a positional argument? Was it as a keyword argument? Do you have too many values? Really horrible stuff. So this simplifies that. All right, so you can do some interesting things with these signature objects. But then you sort of get a new problem, which is that is actually kind of annoying. At least I think it's kind of annoying. I mean, it's like, yeah, okay, you've got signatures being generated there, and you sort of ask this question, well, can you simplify that in some way? And the answer to all questions of can it be simplified in some way is always metaclasses, basically. Okay, so basically you have a problem here involving class definitions, either class decorators or metaclasses. And you could actually solve this problem doing some kind of, either technique. One of the things that you could do is maybe some trick with class decorators. You could say, okay, well, add a signature to this thing, and then use it like a decorator. You could just say, okay, add a signature, name, shares, price. And then it would sort of drop that on there. I'm not sure I don't know, it kind of works okay, but I'm not sure I really like that. The other alternate approach would be to define a sort of a metaclass to do this. So what this is doing, let me just sort of quickly describe it. It's basically making the class, and then after it makes the class, it essentially makes the signature automatically for you, and then just sort of drops it on the class. So it's basically doing code for yourself. It's kind of automating this thing that's kind of annoying. So it's actually setting that field's attribute. So this is if you took that approach, you could actually simplify this code back to what it was initially. I mean, essentially, what you would do to do this is add this sort of meta class that does this like signature generation in there. And then you would sort of use that as your structure-based class, and then you could actually go back to this like simple thing. Okay, so you could hide the fact that you're doing that. Okay, so you're going back to what you had before. Okay, so let's so that's sort of taking you back to that simple definition. This actually is one way to view that is, I mean, this is actually one of the powers of some of this meta class stuff, is that you can actually take like classes and then sort of tweak the definition a little bit or simplify what's going on behind the scenes. I mean, I actually want to make signature objects, but I don't want the user to have to worry about that. I'm sort of saying, okay, well, I'm going to automate that. And the way that I'm going to do it is basically injecting a meta class in there. All right, let me see how people are doing with that. Everyone, okay, so I haven't seen too many people running out in a panic yet. So, that's one thing. One other thing that I guess I would mention too with some of this meta class stuff. Let me go back to this like decorator thing. One thing with decorators versus metaclasses, I think, is this element of how much stuff are you going to put into a base class. I don't know if that's going to make sense, but it turns out that if you're going to expand the structure class to have lots and lots of functionality, like maybe repr methods or type checking or anything like that, that actually might be an argument for doing some of the metaclass stuff. I mean, it turns out that when you're working with metaclasses, you're kind of more deeply embedded in the type system, if you will. And if you need to do things like type checking or propagate code, that is probably something to consider. You know, sometimes you'll hear people say, you should never use metaclasses. It's like too confusing, too mind-blowing. It's like, just use a decorator or something. I'm not sure I totally buy that. I mean, it's, you know, you do have to kind of think about like the problem that you're solving. And, you know, one little subtle aspect of that is that generally with a class decorator, what you're doing is you're just sort of tweaking some class, maybe all on its own. It's just like, oh, take this class and do something to it. Metaclasses actually come into play if you're trying to do some kind of modification, maybe in combination with inheritance. Okay, so it's a more powerful idea. But one thing to keep in mind is that I don't think you should quickly like dismiss any option when you're doing this metaprogramming stuff. I mean, it's like all of this stuff is meant to work together, but it's used to solve sort of different kinds of problems. So there is that element there. So let me just pause for a second. Question in the back, and so you have to shout it out. I'll try to repeat it. So.
The signature attributes, is it significant in Python apart from this demo? Or?
Okay. Yeah, the question about the signature attribute apart from this demo, I think it actually is significant. Like there are parts of Python that look for that, like actually the inspect signature function, like if you say print, like that thing that I just did there, print inspect signature, actually looks for that double underscore signature object. The one thing that is missing, I don't know that there's any core developers sitting in here, but it turns out that the help function does not look at signatures for some reason. And it should. I think it should, actually. I mean, it comes up and basically it says star arg, star keyword arg. I can't think of any reason why the help function shouldn't look at it. It just may be that it's such a modern feature that it just hasn't worked its way out. But there are parts of Python that are looking at that. I could see IDEs, like people writing IDEs for Python that this is something that they may want to tuck away, saying maybe we should look at this signature attribute to find out what the signature thing is. I believe that signature might also be propagated by decorators as well. Now, I'd have to double check. Like that wraps thing may propagate the signature as well. So I'd have to check that. But yeah, there is a significance to the naming of that. Another question here.
I have a different approach to this kind of constructor thing. You can just look at locals the first thing. You take in it, you look at locals, and then you set the locals the name. You keep the signature in place as it is, in it, and then you look at locals and write a small helper that just modifies the names of the dictionary. It's just one line. No Metaclass, pretty easy to understand it, but it's not the same thing. So it's a more lightweight solution, I would say.
Okay, you're talking about, let me just make sure I understand what you're proposing.
And then you go to the locals and you pop off self, you delete the self from the locals section, and then you just set it. Same thing you did with name value.
Okay, so like here you would be using locals then.
And that's doing the same thing we did.
Okay, I'd have to see that. I mean, I don't want to get into it now, but I mean, I will have to admit that I'm a little bit leery of messing around with locals too much doing this, partly because you can run into problems if you ever start messing around with things like slots and stuff, so. Okay. Okay, yeah, I'll catch you later on that.
So locals arguments are only locals there, and you set them.
Okay. Okay, I'll have to see it in the break or something like that. So yeah, let's not go down that path here. So yeah, question all the way in the back though.
Do you need to bind that in the structure? Can bind be pushed to the metaclasses?
Can it be? Your question is, can bind be pushed to the meta class? I don't think so, because bind is basically executed at the time of instance creation. And Metaclass is more about class definition time. So it's a completely different thing there. All right. Well, let's go ahead and move on from that. Now, one of the things that we're going to do here, I want to talk about the dot operator, owning the dot. I believe that those are the words of actually Raymond Hettinger. I think he gave a tutorial where it's like, you own the dot, man, or something like that. So Python actually provides the means for you to do a lot of customization. And I want to talk about sort of this correctness thing. Okay, we did a bunch of data structures. Okay, so duck type. Okay, so you have this stock class. Okay, stock, name, it's so forth. So you have name, shares, price. Somebody might actually want to do some validation on that, or either type checking or validation, or I don't know, posting on Hacker News or something. I don't know. Okay, so there's going to be this sort of correctness thing, and if you know about this, you might know that you can upgrade attributes through the use of properties. I mean, if you were really concerned about type checking, you could potentially define a property for these things, saying, okay, there's a getter function and a setter, and then in the set I'll do like, type check and value check and all this stuff. And that works. Okay, I mean, you can take up an attribute and you could put a bunch of type checking on it, and your program would crash. The only problem with that is it gets really annoying. I mean, I don't know whether you've done much with properties, but if I had to do that all the time, I think I'd just quit. And, I don't know, open up a hot dog stand or something like that. And it's like I wouldn't want to write code like that all the time in my program. It's pretty repetitive. So you may want to simplify that in some way, but it's actually kind of surprisingly tricky in the example that I've given you there. One of the things that's sort of tricky about this particular case is that I actually have two different things intertwined with each other. I've got type checking, and I have domain checking or value checking going on at the same time. So it's like, okay, that's a little messy. And so you might run into this problem. It's like, well, how would I solve that? How would I structure this? So if you want to do things with the dot, and you want to do it for real, not with properties, but you really want to get into the guts of Python, you're going to do it using descriptors, and basically the descriptor protocol. Now, if you have not seen descriptors before, here is kind of the gist of the idea. So let me make a descriptor class. I'm going to keep it in my file that I'm working with here. Basically, the idea of a descriptor is that you get to own the dot operator. I'll explain this name attribute in a second here. So what you can do is you can write a get method that looks like this. I'm just going to put a print in there for starting, not like that. Okay. So I'm going to lose points every single time I do that. And then you can define a set attribute. Looks like this. Print out the value. And then you can also do a delete attribute. Okay. Let me put in the name here too. Okay. So what you do is you have a class that looks like this. Now, what this is basically owning the dot operator for a single attribute. Okay. So this is essentially going to own the dot for a single thing. And here's how this works. What you would do is drop this into a class definition. Okay, let's say you had a class and you're like, you know what? I want shares to be captured by this descriptor object. What you would do is you would do something like this. Okay, you're sort of, you're putting this thing in the class definition. So you're basically redefining the meaning of dot shares. That's what you're doing there. And it turns out that if you do that, and you try your code, so let's try this out here. I think I was calling this structly here. Okay, so let's say you decided to make an object. All of a sudden, you're basically saying, oh, okay, set shares got set to 100. What's going to happen is you've basically intercepted shares, all the operations on shares. You're setting the getting, the setting, deleting. Okay. Now, one of the things and just for that attribute, by the way, like if you look up price or anything, you're not seeing anything. It's just basically on shares. You went in. Think of it like a laser beam. You went in there and you said, okay, shares. I'm gonna redefine what you're doing there. So, what you can do with a descriptor is sort of do fine-grained redefinition of what happens with the dot. Now, everyone's still kind of with me on that. Now, here's what happens in these descriptor objects. It turns out that this instance argument is basically the instance that you're working with. It would be like the stock, basically, like that I'll just put, a stock instance. And typically what you're going to do in these methods is you're going to directly manipulate the underlying instance in some way. There's various ways that you can go about that, but one of the ways that you could do it would be to do things like reach directly into the instance dictionary, for instance, and just say, okay, I'm going to go down into your dictionary and yank something out of the dictionary. Or the self here, I'm going to go down and into your instance dictionary and drop a value on there. Okay, so this is sort of what's going to happen. Is this thing is essentially you're capturing the dot operator. Do I have a typo somewhere? No. Yeah, there's that problem. We'll just never delete anything. That's that would be the part that we don't unit test and we just ship to see whether anybody ever executes that code there. Okay, so this is the thing that you can do. Basically, you can write a descriptor where you capture the dot operator, and you would say, okay, that's kind of interesting. You define that. You has to go in the class definition, and you're going to get customized handling of the different attributes. Okay, so this is what the code basically looks like. Is something like that. You're capturing get, set, and delete operations. One of the things that's going on here is basically this name attribute is essentially the name of where the piece of data is being stored on the object. Every single piece of data has to be stored somewhere. That's the name that I'm using to store it. Okay, so that's like a key in the instance dictionary. You're doing direct manipulation of the instance dictionary there, and basically pulling data in and out. Now, one little subtlety about this, it turns out that if you're using the same name in the instance dictionary, the get method is actually optional. It turns out that if you're going to mess around with this dict attribute, you can actually get rid of some of the code. I'm going to do that in my example here. Turns out that for getting, I'm not really doing much there, so I can actually get rid of that. So I'm going to get rid of that. Just focus on the set there. Okay, so I can basically customize the set operation. Okay, so do something like that. Now, this is where this is going to start to get interesting. Okay, you're saying, okay, basically the way that you would start using a descriptor is like this. You would say, okay, I'm going to have stock structure, maybe some fields, and then I'm going to start declaring things like name, shares, price, all to be descriptors. I'm basically going to define them as descriptors. Now, there's a pretty good chance that you've seen stuff like this before. For example, if you've used things like Django or Web Framework, you get in there and like you've talked about like the definition of models, right? Model fields and things. They'll say, oh yeah, you're gonna find a class, and one of the fields is like a car field, and the other's like a date field, and then a primary key and things like that. You see class definitions that sort of look like that, and that actually gives you kind of an indication of how this stuff is going to get used. It turns out that you can start building basically checks into this whole descriptor mechanism. Now, so let's say you wanted to do type checking. All right, let's go ahead and add that here. I could basically make a class where I would say, okay, I'm going to make something called typed, which is going to inherit from descriptors. And then what I'm going to do is just, what I'll do is I'll make an expected type here. That's what this is, okay? And I'll just redefine a set method to add a little bit of type checking. So I'll say, well, if it's not, an instance of this of that type, raise a type error. I should probably be using the class there, but I'm not going to worry about it. Okay, so you could do something like that, and then I'm just going to pass this back onto the set parameter for or the set method for the base class. Okay, so what I'm doing here is I'm kind of like extending this basic descriptor. I'm saying, okay, well, I'm going to add type checking to that. One of the reasons why I've got it sort of formulated like that is I can easily specialize this. I can say integer is typed where the type is equal to int, and then float is equal to typed where the type is equal to float. String is equal to typed where type is equal to str, basically building this sort of thing out. And what you can start doing now is I could come down here and I could say, okay, stock, name is equal to string name, and then shares is equal to integer shares, price is equal to float price. Okay, if you've done anything with these web frameworks, all of a sudden it's like, oh, wait a minute, okay, I definitely sort of started to see things similar to that. Okay, so what we're doing is kind of extending this thing out. Just delete that for a second. I'm gonna write this out to a new thing here called typely. Okay, all of a sudden we're doing type checking, so we better give it a new name. And if you try this, let's just try it out. Okay, so what you've got now, okay, typely.py, is you should be able to make these structure classes. I still have that print statement in there, so you see it setting stuff. And it should be enforcing type checking. I mean, you can change things, but if I try to change the name to something else, it blows up. Okay, so it's doing a little bit of validation on the data here. Okay, so you're going to look at that and say, well, that's kind of cool, actually. At least I think it's kind of cool that you can own the dot operator like that, customize the set, and put some validation in there. Let me see if everybody's doing okay so far with that. Guys still with me on that?
I guess the only thing I don't quite get is how this is just a descriptor, there's no magic. So when I do a get and there's nothing there, how does it fall back to the other thing?
Yeah, the question, if there's no get, how does it fall back to the thing that was there before? I think it's just programmed that way. I mean, that might be kind of a dumb answer, but I think just the internals of the interpreter. For descriptors, it looks to see if there's a get method, and if not, there's some default implementation of the get that's underneath the covers. If that's actually undocumented behavior or something like that, then I'm just going to burn in hell for presenting this tutorial. But I have seen that before. One critical thing about that, by the way, though. The name has to match what's in the dictionary. I mean, one really subtle thing about this is that if you look at the underlying instance dictionary, it basically has like price, name, and shares in there. And when you're accessing like s.shares, it actually intercepts that before it hits that instance dictionary. Turns out that if the underlying dictionary had like different attribute names, like an underscore shares or an underscore price or something like that, you would have to use a get method because there would be a mismatch between like the name of the descriptor and the name of the attribute. So, yeah, there are some subtle aspects of that. All right, now let's go ahead and like add to this further. One of the things that we had earlier too is we had the value checking thing. That's actually pretty easy to do too. Like if you wanted to do like a domain checking, you could say, okay, let's make a positive descriptor where we'll define a set method. And then how would you check if it's positive? Well, you would just say, well, if the value is less than 0, go ahead and raise a value error. Some mathematician will probably get me for saying, well, technically that just means non-negative or something like that. But that's fine. Okay. So, okay. So we'll write a new descriptor value. Kind of see what's going on here. It sort of says, okay, we'll just check the value. If it's not right, we'll just raise a value error, and then we'll just delegate to the parent there. Now, you might look at that and say, okay, well, how is that supposed to be used? Well, what if defined there? Does anybody know what that is or how that class is supposed to be used? That's actually an example of a mix-in class. The only way that would actually be used properly is usually through multiple inheritance. Let me show you what I mean. Let's say you wanted to have a positive integer. You would say, well, how would that work? Well, that's basically an integer combined with positive. And let's say you wanted to have a positive float. That's a float combined with positive. I'm kind of doing this on purpose to make everybody's head explode with the super function, basically. So what you've got there is what I'm doing is actually combining like two different implementations. I'm combining type checking and I'm combining value checking together into some new thing, and then I can sort of use that in my class down here. I could say, okay, let's do positive integer and do positive float, and let's just see what happens with that. If I've done this right, I should be able to set, shares. I can't set shares to like a string. Okay, get a type error, and I can't set it to a negative value. Got two different checks going on there, basically type checking, value checking, and some other things. Now, that code that I just wrote there, that is some extremely subtle code like this. It turns out that the order absolutely matters there. Do you know why? It basically, the reason it matters, like let's say I were to flip it around, like I'm going to do positive first, and then integer. If I did that, I would actually be trying to do a numeric comparison, possibly on a non-numeric value. It turns out that it will go in the order that's listed there. So that one actually, like this one, would not actually work like I wanted to. I mean, what would happen is if you did that, like here's what would happen if you said s.shares is equal to like a lot. You'd get a completely different error saying unorderable types. Like what in the world is that about? Basically, the order is sort of messed up with that. So the order absolutely matters. This is going to turn everybody off of multiple inheritance forever here. Okay, so just as a disclaimer, this tutorial, as you'll see in a second, aims to combine every horrible, insane thing that you could possibly have at once. Which we'll get to that as we go further. So you can add the value checking in there. It's like okay, interesting. One thing about this, multiple inheritance is actually being used as kind of a basic building block here. We have all these descriptors, and one way to think about them is they're like Lego blocks that are going to stack together, although they have spikes sticking on it. So you have you're basically going to have Lego blocks that sort of stack together. Just to be clear about that, the super function is not the spike. The super function is the little connector socket there. The spike is just for show to keep coworkers out of your code. Okay. So you have these like little building blocks, and really to understand what's going on here, you have to kind of get into the depth of the method resolution order. This is a big topic in Python. It's I don't know. We could do a whole tutorial on that. But one of the things that happens with classes is that when you use multiple inheritance, Python determines this sort of method resolution order list that orders all the classes. So you'll see this thing going positive integer, typed, positive, descriptor, objects, things like that. This actually sort of defines like the control flow of all those set functions. It's extremely it's extremely kind of subtle, but what happens is when I do like this positive integer thing here, integer positive, it will come into this code and it'll say, okay, integer, that one is first. So I'm going to come into the integer code up here. I'm going to come into this thing. I'm going to do the type check, and then I'm going to do this super call. Okay, I'm going to say, okay, call the super class. Now here's the mind-blowing thing. That does not go to the parent. It goes to the next thing on that MRO list, which happens to be the positive class. So not the parent usually. Okay, so what will happen is that will basically come over here and go into this. Okay, so it will say like, oh, okay, I'm gonna call that. Now we're gonna do the value checking, and then this super call here will basically go up to the final base class. Yeah, so if you see that, actually, if you look at that, and you said something like if we looked at positive integer MRO, for instance, you'd actually sort of see that. It's sort of saying, well, it starts on positive integer, it goes to positive, then it goes to integer, then it goes to typed, and then it goes to descriptor. It basically works its way up through this up through this chain. This is a pretty advanced thing with the super function. I mean, the super function actually kind of gets a bad rap in Python sometimes because people that try to use it, and they may not quite understand its relationship to multiple inheritance. The fact that it doesn't necessarily go to the parent. You can get these diamond diagrams.
The diamond gets collapsed into a tuple.
Yeah, the diamond gets collapsed down into this list. I think that the thing with super is that there are some amazingly powerful programming techniques with like mix-in classes and composition of classes that you can get into with that. The really downside of it is that you can, there's a lot of articles out there on the line, where it's like, Python super considered, dangerous or, things like that, where they kind of rant against it. Maybe it is dangerous if you don't know what it does, but it's definitely a feature of that. Yeah, questions over here.
Really quickly, before we get too far from a basic descriptor, I can still get into the dictionary of an instance and inject a badly typed value there, right? So it's not quite a contract.
Oh, yeah.
Just overwriting sugar on the data.
Yeah. The question is, can you get into the dictionary and overwrite it bypassing all this stuff? And the answer is definitely, yeah. Yeah, if you're evil and you know what's going on, you can get into the dictionary and do things. Now, one of the things that I thought I would add to this, we're almost getting into the break, but I thought I would end with sort of two more descriptor objects that are kind of interesting. It turns out if you like this multiple inheritance thing, which you probably don't at this point, but that's okay anyway. You can take this further. Like here is, I have this already kind of programmed here. You could actually do a descriptor that does something like length checking. And this one is actually going to blow your mind a little bit. Actually, let me move this just down a little bit because it kind of comes into play here. It has a size descriptor, has an init function. Okay, this is probably a technique that you have rarely seen. You're not generally supposed to do init functions with multiple inheritance, especially ones that take custom arguments. You're like, what in the world? Okay, you have to look what's going on here. It's like max len. This is one of these keyword-only arguments. You can only do that by keyword. It takes a star args, it takes a keyword args, and a max len. It then pulls out its value, and then it just does super without the keyword argument. It's kind of like, this is sort of weird what's going on here, but it like takes an argument and then like pulls it out of the calling convention and then just passes all the remaining arguments along. You're like, okay. So then you could do things like this. Or you could say, oh, okay, I'm going to make a sized string, where it's like, oh, string it's a string and it's sized. It's like, okay, that's kind of interesting. What's going on there? The only thing that would make that even better. You'll love this. No, not Metaclass. No. You know what it is, though. It's you probably know what it is. It makes everything better. It's regexes. Okay, so you could do something like you could do like this. You could say, well, this is a regex descriptor that takes a pattern, does like a pattern match. And now you could do things like, well, let's have a sized regex string. It's a sized string regex, tons and tons of multiple inheritance here. You can never have too much, especially with regexes. So you could come down here and you can say, well, okay, well now this name thing, this is like like a sized regex string or name where like the pattern, you could basically specify a pattern, it's going to be A through Z plus star and max len equals 8 or something like that. Okay, so now you have keep in mind this is like really freakish, weird stuff going on. You have like two different init functions being combined together with different arguments. Okay, one has a pattern argument, one has a max len argument. They've been like sort of merged into one thing. And it will basically work, assuming that I have made no typos here. So, okay, so if I've done this right, I shouldn't be able to set like a long string because it's too big. I basically set a max length of 8. I also should not be able to set like a bad pattern, basically, so that's an invalid string. On top of that, it's got like you can't set a type. So this thing has a whole bunch of things going on. It's like type checking, plus regexes, plus length checking. You've got a whole bunch of crazy composition through inheritance. And you've just left the building, basically, here. Okay, so okay, so I kind of go through those slides there, and this whole business with this init function, I think is actually a kind of a wild, underappreciated thing about keyword-only arguments in Python. It turns out that the ability to do these keyword-only arguments actually opens up a really kind of interesting new programming technique that allows you to like compose functions involving the star. Like you could have a function with star args, star keyword args, and then you could have this extra keyword argument like stuck in there. And it turns out that those keyword arguments, like if you pull the argument out and then don't pass it along, you can actually get these functions to like compose with each other in any order. They'll like each one will like take its own argument, like pull it out, call it other functions, and it will just like all work. You could probably do this in Python 2, but it is not nearly as elegant as that. I mean, that's a very sort of sneaky idea. Yeah, this is I don't know if you can see that. You see that there, it's like awesome, man, with like all this multiple inheritance craziness. Now, it's still kind of annoying, all the code. We're trying to type there. I mean, we have the fields thing, name shares price, a little bit annoying. So let's take a break. That's the sneaky apocalypse now scene there. So when we, I think it actually is break time. I'm showing like about 2:50. Do you guys know in the back the tutorial guys? Is it about? Okay, I'm going to declare it break time. So I think we have like is it a 20-minute break for the something like that? Okay, so 20 minutes. We'll come back and then we'll build on this. Okay, with AV. Thumbs up on that. Okay. The thing we're going to start with here is this annoyance that we kind of ended with. I mean, we've been messing around. We kind of have two different things going on at the same time here. We've got this signature checking stuff, and then we've got this type checking, value checking stuff. And they're not really unified together very well at this point. One of the consequences of that is that there's sort of a lot of repetition in the definition of these classes. Like there's the declaration of the fields, and then you have, repetition. Like how many times does name appear in there? It's like it appears there's name there, there's name over on the left, there's name in the string there. Quite a bit. It's quite a bit of sort of repetition. And if you have that problem, you may want to push this a little bit further. Of course, you know what the solution to the problem is, right? It's yes, metaclasses. So let me drop that on there and show you what happens with this. So it turns out that you can solve that sort of problem by introducing a new meta class into the mix here. So I'm going to change the meta class that I had before. Let me make sure I have this right. To do something a little bit different here. Okay, so it's almost the same code as before, except I've got I've got a couple of new things going on. The first new thing that's going on is the use of the collections. I'm basically using an ordered dictionary all of a sudden. Hopefully you know about that. If you haven't seen that feature of Python, there's basically a dictionary keeps things in order in the collections module. And then what I'm doing in my meta class is I'm basically adding a new method called _prepare. I'm like, double underscore prepare. This is a new thing. This is a Python 3 thing that you do not have in Python 2. And what this method does is it returns the dictionary that's supposed to be used during class creation. Okay, so like when you execute the class body, it executes in a dictionary. That returns the dictionary that's going to be used. And you would say, well, why would you care about that exactly? Well, the thing that you can do with that is it lets you completely get rid of the fields attribute. You can basically take that, you can say, goodbye. And what will happen is it will record the order of the attributes based on the order that they're listed in the class. This is very, very subtle, right? It's like okay, I'm going to pick up the order there. And then, so that's one of the things that meta class is doing. It's essentially, that's what this is doing. It's essentially saying, okay, I'm going to just pick up I'm going to go through the class dictionary, look at all the things that were descriptors. It's special because it's actually going to keep them in order. Okay, that's the whole feature of this ordered dictionary. Keeps things in order. The other thing that you can do at this point is go ahead and fill in the name field. It turns out that the key of this fields list is actually the name that was used in the class dictionary. So I can get rid of that as well. So you can come in here, you can say, well, okay, let's get rid of that. You don't need to specify the names anymore. And so what's happening is that you've greatly reduced the amount of excess typing there. This is actually looking a lot more like what you might see in Django or something, where it's just, name is a regex string, shares is positive integer, price is positive float. You actually have this sort of meta class kind of doing this stuff for you behind the scenes. So, and the magic for that is this prepare method. I mean, you can't do that with, well, you could do it without the prepare, but you have to do like a worse hack to get it to work. I mean, there's some techniques that you can do for that, but that's basically that prepare method returns some dictionary and then uses that for the execution of the class body. Just and again, what ends up happening there is you're going to record the order of the definitions in this ordered dictionary, and then the fact that they're ordered lets you collect this, basically lets you get the fields attribute. You can automatically sort of produce that, so you don't have to provide it anymore. I don't know, everybody see that there? Yeah, question up here.
Is there a guarantee in the language that the class body won't be subject to any pre-processing that would change the order? Or is that just a convention that we can rely on for now?
Yeah, the question is there any guarantee that something in the language won't change the order of execution? I'm not aware of anything that would change the order of execution, unless somebody's like doing source code rewriting or something.
Like fancy compiler.
Yeah, or compiler trick or something. Yeah, but yeah, that does record the order. There is another kind of angle on this stuff. I'm not going to explore it too much, but there are other things that you can do. Like if you wanted to make even more complicated dictionary objects, like you could make something that inherits from ordered dict and then does things like duplicate detection. I mean, you could actually write code that does some things like generate error messages for duplicate entries and class definitions. I mean, this is sort of like open territory. I mean, one of the things that I kind of explored, it's not in this tutorial, you can do things like multiple dispatch on methods, doing tricks like that. Like you could have a class dictionary that would record the methods that have been seen, and then if you ever saw like the identical method name again, you could like look at that and do things with like this, like look at the signatures of the methods and then try to do like a dispatch function, and basically giving you like overloading or something. I'm not sure I would advise doing that. I mean, it's sort of horrible, but I mean, there's various like opportunities for evil kind of doing that.
It just has to respond to that idea.
Yeah, it's just a dictionary. Any mapping object will do. So that's actually what's going on in that code. It's basically just collecting all the names of stuff in the class. I'm only looking for the ones that are descriptors, though. That's kind of a critical feat. I'm not interested in methods or anything like that. I'm just interested in the ones that were basically derived from that descriptor class that I made. So I'm just collecting those, making the fields. And then you also get this simplification that the names are sort of coming from the dictionary keys. So I'm kind of reducing that down, getting it much simpler there. And then you just sort of keep the code the same. So you can keep the class, keep the signature the same, do all the stuff basically the same. Now there is one little minor technicality. If you're going to do this class stuff, it turns out that when you actually go to create the class, like the real live working class, you cannot pass in an ordered dictionary or any custom dictionary at all. I think it actually has to be a full, proper Python dictionary. So one of the things that will happen is that, if you do any of this like custom dictionary stuff, you're sort of free to use that all the way up to the actual point where the class gets created. But at that point, you have to turn it into a real dictionary. If you don't do that, you get some sort of weird cryptic error message, I think, by doing. Actually, I'm not even sure what the actual error message is for that, but we could try it and see what happens. So like here, if you don't turn it into a proper dictionary, let's just see what happens with that. Well, actually, it did seem to interesting. Class object. It will just fail randomly? Yeah, maybe. I hope it doesn't fail randomly. Well, I have to check into that. I know that I have run into problems with that.
You could create an object and type in stick.
Yeah, let's see what happens with that. Well, it seems to be working, but I'm not real convinced about it right now. Huh. Okay, well, let's not go there. I'll leave it uncopied for now and just see if it breaks later on. Have run into trouble with that. So that's one thing there. Now, yeah, all right. So now we're getting into some problems here. Okay, performance. Okay. Would anybody care to hazard a guess about what's going on with that? Okay, so we just added a whole bunch of stuff. We added like the signature stuff, the generalized init, the type checking, value checking. It's not good. It's not good what happens here. So if you, yeah, it's bad. So you have the simple class versus all this meta stuff, and it's like, oh man. Okay, so 86 time performance hit on instance creation. Might be able to do that better using this trick that Mike showed me, although you'd still take a hit there. I'm going to post that after the tutorial. One shining spot, attribute lookup, unaffected. Now you say, why is that? It's because we didn't implement get method. We didn't implement it, so it's using the default. It's nothing's there. Assignment operation is also not real great. Like 30 times slower for that. Attribute for the name, that's like 58 times slower. I mean, keep in mind it's doing type checking, it's doing a regex match, it's doing a length check. There's a lot of stuff going on in there. So, question here.
About how much faster or how much slower it is based on, look, we're doing this actual processing on it versus we're running the MROs.
Yeah, I haven't really broken that down. Yeah, there's a lot of stuff going on. It's like MRO chasing.
But there's also actually checking to make sure it's the number of positives.
Yeah. The actual checking is probably the minor part of it. Yeah, we'll see that. So what we're going to do here, this is going to be so bad. I'm just going to say I'm going to burn in hell for what's about to happen here. So let's say you wanted to speed this up in some way. Yeah, the bright spot there. Yeah. Okay. So a bunch of bottlenecks in here: signature enforcement, multiple inheritance, super. Can you do anything without a total rewrite? So here's one thought. It's so bad. What if I just started producing source code? This is such a bad idea. Okay, so let's come up here and do that. Okay, so let's say I have I think this is frag 6. Okay, make an init function. Okay, so let me just put that in there. I'll talk about it. Okay, so what this is it's like you give it a bunch of fields, and it just makes an init function for you. It's kind of stupid what it does, actually. So the way that it works is you would just say, okay, underscore make init, and then you just give it. Let me do a print on it so you can see it a little bit better. It's just like, okay, make an init function. There it is. Okay, so yeah, okay, you sort of see where this is going. You could say, okay, where's he going with that? Basically, you say, okay, I could take a list of fields and just make an init function. The obvious thing that I should do is just combine that with metaclasses. Let's just like put it in a metaclass. Okay, so what you could do here is you could say, okay, I just made like here. Okay, I just made the fields. So why don't I just come down here and just like make an init function? What I'll do is I'll just say, you know what, init code is equal to make init out of field. Actually, I do need to probably put a little check here. If there actually are any fields, I'll do this. So I'll just say, okay, make an init, make the init code, and why don't we just execute it in the class dictionary that just got created here? Okay, so I'll do global. I'm a little bit uncertain about that, but what I'll do is I'll just execute it in the class dictionary, and then I'll just pass it on to the thing there. Okay, so you're saying, oh God, I'm going to hell for that. Okay, so in theory, if this works, I should just be able to get rid of the init function here. Let's just delete it. Okay, time. Let's just do that. I'm gonna save this as a new thing here. Exactly. Okay. So all right. So what's going on here is it's gonna say, I'm gonna say, okay, I'm just gonna make an init function. Hope that the thing works. Actually, if I'm making an init function, I don't have to do the signature stuff anymore either. Yeah, let's get rid of that. Okay. So I don't need to do signatures anymore because the signature is basically coming from the init function now. So okay, so let's try that, see what happens. This will either work horribly or not. Let's do a help on stock. This will tell us if it. Okay, name shares price. That looks good. Should work. Okay, so. Still has the type checking on there. Okay, so everything is the same, but basically we're generating code using the exec function and some like code generator stuff. Everybody still okay on that? In my defense, I will say that the collections named tuple object uses exec, and since it was written by Raymond Henninger, I feel fully free to use exec. Here, okay, so what?
It returns its own source code.
It returns its own, source code, yeah. So you could do that. It's like, okay, that's kind of cool. You don't need signature anymore. It does run considerably faster doing that. So if you do that, it went for the simple class went from like. Instead of 1 to 91 seconds, now it's running in 17 seconds. So definitely took a big hit on, big drop in increase in performance by doing that trick. It's still not going to be as fast because I'm doing a lot of type checking. I mean, there's sort of an unavoidable amount of type checking doing there. But then you can kind of take this a bit further, and you're like, huh, I wonder if okay, I got all these descriptors. You're gonna like this. This is gonna be good. Wonder if we could do something with those. I've got all these little code fragments for these set methods. Wonder if you could do something like stringing those together in some horrible, evil way. And here's an idea on that. This is going to be bad. What if I were to? Okay, let me get rid of the print here. I'm gonna change this into something else entirely. You'll see why this has to be a static method in a second. You're like, oh, good God, what is he doing now there? Okay, so what I've done here is I got this like set code. I basically took the code and just put it into a string. I'm like, oh man, I'm gonna go do that for all of these. It'll take a minute here, but it'll give you time to have this sink in a little bit here. Okay, so I'm gonna start producing. I'm gonna start making the code basically as strings. This is so bad that it's good, basically. Okay, so I'm gonna get rid of the super here. Okay, so if super is gone, you'll see why in a second. Okay, so I'm going through all these classes, changing the set method into this like weird set code thing. We got a little bit of a quotation problem here. I got to be careful with that. Okay. Job security is going up considerably at this point. Yeah. So we have let's do this. We're almost done here. Okay. So. I wonder what part of the Balmer curve we're on at this point. Let's see, if people know about that. Okay, getting rid of the super function too. Got to make sure that okay, get rid of that. And I think there's one more that I need to do here. Is there one more that I'm missing? Is it? I still have to fix some quoting stuff. Okay, so going through all the code, and it's like I basically changed all those into like I'm returning string code fragments. And you're like, oh man, okay, what in the world is that going about? And what is he doing here? So what I'm going to do is basically take like all those code. I have these functions that return like code fragments, just to sort of see what's going to happen here. Let me just run that kind of in its partial state here. Essentially, what happens is if you take descriptor and you call set code on it, you get like a fragment of code, and then if you do like typed set code or like integer set code, let's just do that. You get a little fragment of code like that. So every single one of these is basically produces like a little code fragment. You could say, okay, well, what in the world? What would you do with that? Well, what you could do is you could say, well, let's make some code that basically starts out like this. You could say, let's define a set method, self instance value, colon, like that. And then what you could do is you could say for class in like positive integer dot MRO. For line in class set code. code append, I got to add like an indentation to it. That's kind of why I added that thing like that. What did I?
Oh, because it goes all the way back up to object.
Did I? I must be missing something somewhere.
Check to see if there is a set code. Yeah.
Yeah.
Well, you get the idea. Let me see here. For line and class, that okay. Oh yeah. Okay, yeah. Okay. It failed, but we got the code anyway. Okay, so yeah. Okay. Well, okay. So you get the idea here. Okay. So what we're gonna do here is we'll basically join all that code together. And you have this. Now, I kind of screwed it. There's a few things that are a little bit wonky here that I'm going to fix in a second. But you kind of get the idea where this thing is going. It's like, okay, I'm basically going to walk the MRO, and I'm going to like I'm basically going to concat a whole bunch of code together. And you're saying, oh, this is so wrong, so level here. So let me. I think I have the code for this. So let me pull this in here. Okay, so what I'm going to do is basically write like a little utility function that sort of says, okay, make setter. Okay, so this thing is going to make that set function. The only thing that's a little bit different about this one is that I actually only do it if it's actually literally in the class dictionary. This actually avoids some of the repetition, like getting it more than once. So it's going to go through there, make a whole bunch of code. Yeah, the flames are getting really, really hot now. Okay, so we're basically doing these set code methods, and then we're gonna have all the descriptors kind of go through there, combine all that code. And you're saying, okay, that's kind of interesting. We have to have the setter function there, but then we have to figure out some way to get this to work kind of in a nice way. Okay, so this is what it's doing, basically making the set function, and then. I don't know, anybody care to guess what is needed at this point? What? Yeah, you need the exec and other stuff. Yeah, what you really need here is actually another metaclass. Turns out you need a metaclass for your descriptors now. Okay, so you're gonna say, oh, okay, we're gonna make a metaclass type. Just let's do something like this. So what I'm going to do is I'm going to basically define this using an init function. You're going to say, okay, how is this going to work? Well, I'm going to basically this init is going to create the class. Okay, so let's just create the class first. And then what I'm going to do is execute that like set code thing. So what I'm going to do is I'm going to make like the code is going to be equal to make setter of myself. Okay, keep in mind with a meta class, it's like you're talking about the class. So this is going to make basically make the set code, and then I'm just going to execute the code. Yeah, I'm going to execute the code basically in the class. I'll do it in the class dictionary at this point. So we'll execute it in the dictionary. And let's just see what happens. Let's just see what happens with that. Actually, one thing that I know you have to do here is copy this over. This is kind of a weird technicality, but it turns out that this class dictionary passed at this point is not the actual one being used by the class. I used it for the convenience of using the exec, but you do that. So this thing is going to, it's like, okay, what in the world is going on with that? This is basically going to execute those set code methods for me, and then produce a set function. There's so many things that are so wrong about this at this point, but that's what we're doing there. One little quiz question about this. This is for the experts. Why is this being done in the init function of a metaclass as opposed to the new function of a metaclass? Yeah, it was partly like to create the class. I have to do it there because the generation of the code actually requires the MRO to be established, and I can't do that if the class hasn't been created yet. That's one subtlety of that. So, okay, so we're going to do that. I don't know. Let's just try it and see what happens. Okay, so this thing, just to be clear about what is going on, set attribute. Got a little typo there. Set attribute on myself here. Okay, that's. Where? Okay, can you repeat the question? Here, let me.
The last statement, set atter, so set. I thought the whole purpose, the block before it creates the segment for us and then gives us. So why do you do it explicitly now?
Oh, why am I doing this? It turns out that when you create a class, Python often will copy the class dictionary into its own thing. I mean, it's sort of a subtle feature, but if you look at it like a typical class definition, like stock, underscore, there's your class. If you look at the underlying dictionary, it tends to kind of get wrapped up with some extra stuff. Like, I mean, you sort of see like, oh, it's a mapping proxy. It's like, okay, it's not really, it's like a mapping proxy object. You'll actually find that it's a read-only dictionary. Like, you can't put anything into it. You get like a type error. For various reasons, like when the class gets created, the dictionary that you initially received in a meta class is not necessarily the one that's being used for the class. And so that's actually what's going on there. It's I'm using the dictionary that got passed in just to do the exec, mainly because I guess I'm being lazy. It's like, well, I already have a dictionary there, so I'll just use it. I use it to make the set function. So that is a little bit of a weird thing. It's like, I'm execing this thing, but then I got to copy it over. Okay. I'll just put a note, yes, this is weird. Okay, so yeah, so that's what's going on there. So what's going to happen with this? Okay, so assuming that this worked, and I'm not sure that it did, but we'll find out. Is you should be able to do the different sets. It's basically still working, but it's generating the code kind of on the fly there. Very scary. Now, one thing you might want to do, this is actually a little bit of a frightening thing. It's like, okay, you're making descriptors, but you're not using the underscore set method anymore. You're doing like code generation stuff. One possibility that you might want to account for is whether somebody would define like a traditional descriptor hanging off of that. Like if somebody were to say, well, here's my class, my descriptor inherits from descriptor, and then for some reason they didn't know that you were doing this like this horrible magic like that. I'm just put a pass in there. That actually might be something that you would want to either shut down or error check for. I mean, and you can actually do that. I mean, one of the things that you could do in this descriptor meta class is you could essentially look at it and say, you know what, if there's some method set in the class dictionary, raise like a type error or something like that, Okay, so if you had something like that, let's see what happens. Now you get basically an exception saying, okay, well, this thing that you've defined is not proper according to what the coding convention is. So there are different things that you can do there. It is a little bit scary doing exec though, although since name tuple does it, I can get away with it. So if you make that change, okay, do a little metaclass stuff. A whole bunch of interesting stuff is happening. Just to be clear about it, the user of this has no idea whatsoever that this is going on. I mean, it's like they're using these classes I didn't make any change to the stock class. This is all behind the scenes magic in descriptors. Turns out that it really does some nice things with the performance on that. So if you see what happens here, it went from like 86 times slower down to 6.7 times slower. About 3 times faster with attribute assignment. It's basically a pretty big speed up across the board. I mean, one of the things that happened, I mean, you just eliminated like a whole bunch of machinery. Like you got rid of the super function. You even got rid of function calls. I mean, you're not even like, you know, it's just like one function that's just doing the code there. How scared are people? There's a question in the back there.
So, then, if you advise someone to write the metaprogramming, would you suggest the first method or the second method? Because the second method is too much of writing strings and exec.
Yeah, I would do the question is, would you do the first method or the second method? I would probably do the first method. The reason I'm kind of doing the second method is just to explore the space of possibilities. I mean, it's like, wow, there's some wild things that you can do. Getting into like execing code and like having metaclasses like form code fragments and do all sorts of other sort of crazy stuff. Yeah.
I hope that this remains a theoretical question, but could you write a preprocessor that moves meta into exec with some guarantees as to correctness?
Yeah, the question is a preprocessor that moves. I don't know.
Sort of like explicit loop unrolling, right?
Like
it the dry way and then it actually does it the wet way.
Actually, yeah. The question is, could you? Yeah, that's an interesting question. Could you write code like this is basically the question? Could you write code that would take like the normal set functions and then do something with them to combine them? And
You could look on the code objects that are defined on the methods and exec them in turn.
yeah, I mean, I could think of like a few ways to do that, like processing source or maybe processing Python abstract syntax trees. I'm curious to see what Mike has to say about this.
Maybe PyPy is doing something like this already.
Try it in PyPy to do this.
I didn't say specifically Python 3. It seems like it should work with Python 2, I guess.
Yeah, just run it on PyPy. Yeah, I didn't look at that. I don't know. Let's not bring PyPy into this insanity. The insanity of all this. It actually brings me to this. Okay, so the horror. I don't know whether that's Alex Gaynor, who's very dark in that photo. You can't even see that. So the horror. You kind of look at this and say, well, this is insane. It's kind of you look at this. They're actually, I'll have some time here. One of the things you might look at this and say, okay. This is just madness, It's like, how would I? Kind of the remaining question here is how would you convince some manager that this is a good idea? I mean, it's like so far off the rails at this point that you're like, and so the answer to that is clearly XML. Yeah. So we're going to do, this is going to like push it over the edge here. So what I've got here is, this actually might answer your question about generating code on the fly here. So let's say we have like an XML representation of the data here. I will note, by the way, that this is XML that additionally includes a regex. It's like a bonus feature, regex and XML. Okay, so you have XML. Yeah, five extra credit points there. So like what in the world would you do with that? Okay, let's kind of work through this here. Okay, so let's say I wanted to turn XML code into Python code, into structure code. So to do that, let's come down here and add some more code to this. So the idea here, okay, this is our XML parsing stuff. If you want to parse XML, just use like the element tree module. That's a pretty easy way to do that. So the first thing that I'm going to write is basically maybe a function that's like XML to I don't know, like code or something like that. Okay, so I'm gonna have this take maybe a file name as input, and it's kind of like, okay, well, how do you parse XML? Well, we'll do a parse on that. And then I think the way that this XML is structured, let me just look at my notes to make sure I'm not completely off the deep end with the thing here. Okay, so the XML that I'm showing there, I basically have these like these structure elements there. Okay, so I'm gonna walk through this XML document making code, and maybe what I'm gonna do is I'm gonna take I'm gonna call a function like, you know, code is equal to or like class code is equal to XML. Well, maybe struct to class or something. I'm going to start off with some code here, and then I'll just kind of build it up. In code. Okay, so I'm going to kind of take this in little pieces here. Okay, so what this is doing is this is parsing a file name. It's going to walk through that, finding all the structures, and then it's going to try to like build up kind of like a code fragment from that. I'm going to write another utility function here, like struct to class, where you give it like a structure element, and then it's going to pull some things out of that. Like let me look at the schema here. Okay, so like the name attribute. Let's just start with that. I'll say structure.get name, and then I'll form some code here, basically saying, okay, this is going to be something called class with the name, inherits from structure, and I don't know. Let's just return that to start here. Okay, so this I'll build this up here. Okay, so we're going to start with that, and this is this XML file that that I'm working here. Well, actually, I don't want to copy that in there. Okay, so here's what the XML file looks like. It looks something like that. I'm going to write a little bit of parsing code in here. Okay, let's just kind of play with it, build it up a little bit here. Okay, so what I have is essentially, I should be able to say code, you know, XML to code. Let's see what we're getting. Okay, well, we're starting to basically make classes. I screwed up my formatting, but you know, there's other stuff that we need to do there. So we're going to start building up code from XML, from the name there. Then what we'll do here is basically do some more parsing to pull the fields off. So it turns out that in this, if we go back to this XML file, we've got all these like little field elements in there. So what I'm going to use those to generate more code. So I'm going to say for field in structure find all field. And then I'm going to start pulling some things off of this. So let's look at the XML. One of the things that's here is there's basically like a type attribute. That's basically the name of the descriptor. It's sort of saying, okay, there's sized regex strings, like pos integer, pos float. So let's sort of pull that off. So we'll say, okay, well, the data type is going to be field get type. Okay, and then let's look at what else is there. Oh, actually, it's wrong window there. So then we have some other fields. There's some optional like optional arguments there. All right, okay, so let's try to pull some of this off. So the I'll say options is equal to well, I'll say value for key value in field items. This is a little bit of XML parsing, but what I'm doing here is I'm essentially saying, okay, give me all the things that are not the type. The type is kind of extra there. Okay, so this is Oh, I also have a space in the quotes, yeah. That would be kind of cool if it was space insensitive, though, you know. Yeah, okay. So, so we're going to pull off the options there. The name of the thing is going to be, I believe it's just the text attribute of field. Maybe we ought to strip it just to be careful there. And then what we could do is we could say, okay, well, let's add to this code a whole bunch, you know, like some big hack weird thing here. Okay, so there's going to be the type, and then there's going to be the keyword arguments, and then it's going to look something like that. Name is equal to type with some args. So we're going to have the name, we're going to have the data type, and then I'm going to do some horrible thing with the options there. Okay, so we're kind of building this thing up. Let's just try it out and see what happens here. Okay, so okay, it's looking a little bit promising. I think I'm missing a new line in there somewhere, but you can sort of see. Okay, it's saying stock structure, sized regex. It's got the different values in there. Okay, so hopefully you sort of see what's going on here. I'm basically turning this XML into a Python class definition. There is a method to this madness, by the way. I'll get to in a second here. So. Okay, so this is what's happening there. It's like okay, we're building up class definitions. These are the same class of definitions that I was working with before. I do see one little problem in the way that I've written that. I did not include the keywords with that. So let me see if I can fix that. Actually, one of the things we could do here is actually just make a string that just said. Like that. So let's try that. Okay, that's looking a little bit better. Okay, we got keyword arguments there. Okay, so we're building up some code. Still a little scary there. Is everyone good with that? Now, one of the things that we don't have in this code. If this is code that's going to exec in some way, we do need to bring in the definitions of like structure and all these descriptors and things like that. I don't really know like how you want to do that. I guess I could put a method or add just an import statement to this code. Maybe since we're already going for broke here, it's. Yeah, I don't know, why not? Okay, so, yeah, use the import star just to make it for even worse than it already was. Okay, so you could do that, and you basically have, your code is equal to XML code, datadefs.xml. There's your code. Okay, from exactly import star, and then got this like these code fragments. In theory, I should be able to exec that, right? I mean, I should be able to do exec code and have that work. Now, the question is, why is it not? Did I change the name of positive?
Yeah.
Oh, okay. Well, that's the whole reason for doing XML, though, right? So it's you can change the name of things without having to change the code, right? That's the. Yeah. Okay. So. Yeah. Okay. so bad. Okay. You could tell your manager that. Yeah. Okay. You could change the code without changing the code there. Okay. Very good. Okay. You know, the exact function. Okay. Yeah. This is going so bad. Okay. So. So we're turning XML into code now. It turns out that this is leading up to like something else. Okay. It's like okay, we're turning XML into these like code fragments. But you look at this as like this is so stupid. Like why would you do this? Well, the reason you might do this is that you would actually really want to make this work with the import statement. That's what we're really going for here. You know, what would be really cool, this is the thing that would be really cool, is if you could just say, you know what, why can't we just say import like data defs? Never mind the fact that it's an XML file. I mean, okay, so data defs is basically that. Couldn't we just like hack the import statement to do this? So the answer is that yes. You know, why not? You know, why not do that? Okay, so let's talk a little bit about import hooks. How many of you have ever looked at the value of sys.metapath or even know that it exists? You probably know that there's sys.path. That's the directory of like things that get checked when you load modules. But there's this other thing in there, sys.metapath. And you look on there and it's like, built-in importer, frozen lib importer, pathfinder, things like that. It turns out that this is a list of classes that get triggered to process the import statement. So, I don't know, why don't we just do a little example here? So what you can do is you can make a class called myFinder. Actually, it doesn't matter what it's called, but you can make a class and you can put a method on there, find module, where you say, okay, well, where you get like a full name here. It turns out that full name is the name of what's being imported. And path is basically the path setting for packages, actually. So that's a subtlety there. Let me just do a printout of what's going on here. Okay, I'm going to print these out. Full name path, and I'm actually just going to return none because I don't know what to do yet. Okay, so let's say you made a class like that, and then let's say you decided to insert that onto the sys.metapath thing. Okay, so let's say you came in here and you did something like that. If this works, you're going to start seeing print statements that just printed out. It said math none there. We should bring threads into this. Okay, you kind of sort of see what's going on here. It's like, okay, I'm intercepting the import statement. Everyone kind of see that? All right, so what could you do with that? Okay, so so maybe I could come back to my exactly thing here. Actually, I'm going to change the name of it to importly because we're doing import here. Okay, so let's do imports here. So you could basically come into this code and say, you know what? I'm going to make like a special like struct import finder or something like that. So I'm going to make a finder class that just implements this find module thing along with path here. And then you could say, well, okay, how is this supposed to work? Okay, so what we're gonna do here, here's the theory of operation here, okay? Make it import somehow. I haven't actually told you how to do that yet, but so this is sort of the theory of operation. So a couple of different ways that you could approach this. One way that you could do it is you could essentially walk down system path. Well, let me bring in OS module here, and then you could do like some file name things where you could say, okay, like the file name is going to be OS path join dir name along with the full name of the module plus like .xml or something. That's maybe not the most efficient way of doing that, but what you're doing there is you're just saying, okay, I'm going to make some file name there, and then if that exists, we're gonna load XML. Let me just put like I'm gonna put a print statement in here just so you can see it fire. For the purposes, since I don't know how to implement the next part of it yet, I'm just gonna. Do I have a hanging backslash? No, I think that's an Emacs rendering thing there. Yeah. Okay. So let's do that, and then I'm gonna put like a little hack in here, like install importer. That's going to just append this like struct importer thing on here, or struct finder. Okay. All right. Okay. Let's see what happens with that. Okay. So we're gonna do this importly .py here. So if that works, first of all, I haven't installed it. So if I do import data defs, it's can't find it. But let's do the install importer. By doing that. We should see our thing kind of sitting there, okay? So it's like, okay, struct finder sitting on the end. And if we import data defs, it printed it out. It basically didn't find it because I haven't told it how to find it yet. But you see this here. It says, if you look carefully, it says loading XML data defs .xml. Okay, so it did find a file name match. And you're like, okay. I didn't hear the question very well. Can you repeat the question? Yes. No, I wrote that actually. So install importer was just a. Yeah, the question is, did I write install importer on? Yeah, that's something that I just wrote to append something onto that meta path there. Yeah, I'm actually a little bit curious. How many people have seen this metapath thing before? Just so you know, this is in Python 2.6 too, and possibly in 2. I'm not sure about 2.5, but it's definitely in 2. Is it in 2.5? It's been there for a while.
I've worked with custom importers, but I didn't know the exact mechanism.
Yeah, I think there have been like custom importers around for a while. I think some of the tools that use those are some of these like freezing tools, where you can freezing tools. Other.
Where I work in encryption, we actually encrypt the egg and.
Yeah, encrypted source code. Yeah, question over there.
So, for your custom fake importing thing, why does that have to be added to Metapath as an object or like an instance of that class, but everything else in Metapath is just a class?
Oh, I think well, that's a good question. Yeah, I don't know. They might be implementing it as a class method, maybe. That's actually a good observation. Yeah, the question is, why is everything here a class and not an instance of a class? Actually, I didn't really notice that before. I guess you could go that route if you were to declare find module as a class method. Maybe if you don't have any like instance state or something, you could do that. Let me just try that and see if that works. Yeah, it still works. I mean, they've probably defined that as a class method of some kind. I actually have to admit, I never noticed that before. So I just know that whatever is in the meta path has to support a find module method, whatever it happens to be. So whatever thing is in there. Now there was a question over here too. Maybe that answered the question there. Okay. Now it turns out that we're still not done with this thing. Okay, so this path exists thing. It's like, okay, loading XML. Now the question that comes up now is like, now what? Okay, so what do we do here? It turns out that to get the module to load, we actually have to return something else. We have to basically return like a loader object, and this is actually something that I'm going to have to write myself. So, so what I'm going to do here is basically return a you know, a quote loader, and what that class is it's going to look like this. It basically has to have a method on there. I believe it's just load module, and I might take the path too. I'll have to double check this in a second. So. I'm going to have this take a file name value just because I located the file name, so I might as well just pass that along there. Okay, so we're going to put a load, this like load module thing in there. I'm going to take a quick look at my notes just to make sure I'm not going completely off the rails here. Okay, so actually you just need the full name of the module. Okay, so you're going to put this load module thing in here. Now, what you have to do at this point is actually carry out the import. Okay, so this is what we have to do here is basically carry out the import steps. And you could say, well, how do you carry out an import? So there's a number of things that you have to do here. So what do you have to do with module importing? Well, first of all, modules in Python are basically their own objects. Like, you know, it says module math, or if you import URL lib or something like that, and look at these things, they're basically like a module instance. There's like an instance of a module that you make. It turns out that there's a library. You can import the imp library, and you can make modules with that. I believe you can, yeah, let me see what it is here. It's, yeah, new module. I mean, you basically say, okay, make a new module called foo. You have a module object. Now, there's not a whole lot interesting in that at this point. It just sort of has like a name and nothing else. But you can sort of make a module come into existence. Okay, so that's what we can do here. We can say, okay, well, let's we're going to make like the mod is equal to imp new module full name. Okay, so we're going to make the new module. Now, module imports actually do more than just make the module. One of the things that you have to worry about is there's also this sysmodules cache that you might know about. So sys.modules is basically a cache of all the currently loaded modules in the system. In order to do an import, you actually have to maintain that cache if you want to. I mean, you could not if you chose not to, but generally you do. So what you're going to do is you're going to make a module, and then what you have to do basically at this point is insert it into the module path. Now it turns out that there is sort of a weird technicality here that if the module already exists in the module cache, you're supposed to reuse it. I mean, this is all this like module reloading, using the same module, that sort of stuff. So you basically have to do some things here. So let me import sys here. So what we're going to do is sys modules full name equals mod. Maybe if the full name is already in. Okay, so we're having to kind of reorganize this a little bit. This is some basically we're creating the module and then we're putting it in sys.modules. Okay, so this is some basic background stuff. Then what we have to do once we bring the module in is we need to set a few parameters. One of the things that we need to do is basically set the file parameter of where this thing came from. Another thing that you need to do is set like what loader is used to make this thing. So you're gonna set up some things like this, and then return the module back. Okay, so this is what's going to happen in this load module thing. So let me actually try this real quick without doing much of anything yet. Okay, so we're gonna write this loader that's basically making a module. Okay, install importer. I'm going to do import data defs. It comes up and says, okay, it says loading XML. I actually have not done anything with it yet. But what it's going to do is it's going to say, okay, datadefs is some module. And it comes up and says, oh, it's from the file datadefs.xml. This is probably the worst nightmare that you would ever have, right? It's like you're looking at your Python code and it's telling you that the source code for your module is an XML file. That's okay. So you have that. Now, to make the rest of it work, you're saying, okay, what do you need to do here? Well, to make the rest of it work, you're going to use that XML stuff. You're going to say, okay, XML to code, file name. That's essentially using this thing that we just did up here, the XML parser. So we're going to read that code and parse it and turn it into a code fragment. And then what do you do with that? Well, you just exec it in the module dictionary. Okay, the flames are getting really hot now. Okay, so this is it's basically you're hooking into the import statement, parsing XML, making code, bringing it in. If this works, I'm not sure it will, but if you do this, so we should be able to say install importer, and then we should be able to say import datadefs. Bring us into the loading message. Should be able to do a dir on it. Now, because I did the from import star, I'm in like kind of a tough spot here, but it's like you see stock and some other things in there. I should just be able to do datadefs.stock. Okay, so yeah. Okay. So you've sort of so now what you've got. Okay. And again, the source, your data defs, that's in the datadefs.xml file there. So many things wrong with this on so many levels there. What? Tried it. Can you repeat that again? Yeah, so the question is, could I, if I understand it, could I redo the example in the test-driven development style? The answer is no, obviously. Okay, so, all right, so a whole bunch of stuff here. You're like, oh man. Okay, so we're basically hooking into this this structure importing machinery. One little thing about some of this import hook stuff is Python 3.3 really builds that out in a big way. I mean, actually, one of the big changes in Python 3 is that the entire import machinery for Python itself has been implemented in Python using the import hook machinery. And because and that's actually a big difference between like Python 2 and Python like 3.2, even 3.2 and 3.3. Like if you look at this meta path, you see things like, oh, it's frozen, built-in importer, frozen importer, pathfinder, and so forth. If you switch Python versions, like, you just go to Python 2.7 or something, and you look at that meta path, it's just empty. Now, the reason it's empty is that the import in Python 2.7 is implemented in C. I mean, it's like it's C code somewhere deep in the interpreter. It's like it's not exposed to you. And the same thing even in like Python. Oh, I don't have Python 3.2. Yeah, it's also empty in 3.2. I guess Python 3.2 is dead to me at this point. Right? So, but yeah, that's actually one of the big changes in Python 3.3 is that they have exposed this import machinery to you. I mean, honestly, I don't know how you feel about the import statement. I think it's actually one of the most mysterious black voodoo art things in Python. I mean, it's like, I just look at it and it's like, how in the world do imports work? I mean, it's, actually, I think Brett is somebody, I think one of the core developers is giving like a talk at the conference about how does the import statement work. And he showed me some part of it at one point. It was like this huge diagram of all these arrows and like font so small that I had to like blow it up bigger to sort of see what's going on. But the import statement, very, very mysterious. And that's actually one of the big changes in this Python 3 is basically exposing the import machinery in a more coherent way. I mean, this is documented better. There's like more of a precise procedure that these things are supposed to follow. There's different things that you can do with it. Did some experimentation over the summer of importing LLVM bit code directly into Python using import hooks. And it was like that's kind of its own scary little project there, but.
If you convince yourself it was a good idea, you could directly import, say, a SQLite file and have the ORM all set up for you.
Yeah, okay. Yeah. I don't know, is Peter Wang here, actually? I don't. He pulled me, so Peter is one of the continuum analytic guys. I think he pulled me aside at some conference last year, and he was exploring some idea of using import hooks to directly embed SQL right into the middle of Python source. Like, I don't know exactly the detail of that, but it was kind of the idea is, you could have like source code that would just suddenly switch context to do SQL, and he was doing some crazy import source parsing, some source parsing thing. I don't know really what happened with that, but I was sort of horrified at the time, and so forth. So what we've got here, basically importing modules from XML with regex in there, and metaclasses and all sorts of other stuff. I think if you I don't know whether the import, if you do the get source on this stuff, it actually might show you the XML. Let me actually try that. The inspect module, by the way, yeah, okay. So, very. What's not to love about that? Okay, so some final thoughts on some of this stuff. We're gonna have some fair amount of time for questions on some of this. So, actually, that says airstrike on it. I don't know. It's a little bit dark for some reason. There's a lot of very powerful things you can do with some of this metaprogramming stuff. I think if there's takeaway, I mean, you can have like descriptors as building blocks. Hiding a lot of annoying details, code generation, hooking into import, all sorts of interesting things. And one thing you could think about with this is, is this tutorial, is it just one gigantic hack, or is Python 3 designed to do this stuff? And I would actually make the claim that Python 3 is they're actually thinking about this kind of stuff to make it work nicely. I mean, there's a lot of this like advanced metaclass stuff with the prepare method. You have signatures, you have import hooks, some of the keyword-only arguments. I mean, even though we did some kind of crazy, some crazy things in this tutorial, I don't think I actually did any like just completely mind-boggling weird hack to work around some language limitation. It's saying, well, I have to do this weird hack because Python's broken in this way, and I have to do this workaround. I didn't, at least in my mind, I did not do any what I would call workarounds in here for stuff. I mean, admittedly, there's some advanced things, but there's, a bunch of very interesting stuff. I think there's a lot of little things in Python, or at least Python 3, that just become easier. I mean, there's like tons and tons of like little subtle stuff like that, like the keyword-only arguments. You could say that's such a minor feature, but yet it opens up like all sorts of interesting things, like mixing keyword arguments with star args and like composition of functions and things. I mean, it's a little weird. There's even a lot of like little things that are just really nice about Python 3, like the fact that the compare operator works. It's not a metaprogramming technique, but I mean, I don't know whether hopefully you know this, but compare doesn't work in Python 2. Well, it works, but it works all the time for everything. So it's a lot of stuff like that. A lot of little things in Python 3 that just sort of come together and make things interesting. Now it turns out that we've only sort of scratched like the surface of what is possible. One thing that I didn't talk about at all are things like function annotations. It's like, okay, if you haven't seen function annotations before, I mean, essentially what you can do is you could have a, let's go back to Python 3 here, you could have a function where you say, okay, this is the add function, but then you could like attach things to it. like that. And you can say, well, what does that do? It doesn't do anything. Python attaches no meaning to that at all. But what happens is they're basically stored just in a dictionary. You get this sort of annotations table, and it just tells you what the annotations are. Turns out that those annotations can actually be anything whatsoever. I mean, they could be like a number, or they could be a string. Could be a lambda function. I don't know, you know. Okay, so yeah, the like permanent job security there. Okay, so yeah, all right. So, but it basically just stores that, and you can say, well, what's the what's the purpose of that? What's the purpose of annotations? I don't know. I mean, you could do some pretty wild things combining that with things like metaclasses. I mean, why you could do things like this. I mean, you could say, well, let's have like some class, class spam, and then we'll start doing things like, let's have a bar method that takes like an int, and let's have another bar method that takes like a string. And you could say, well, how, like, you might look at that and say, well, okay, that's clearly so wrong. I mean, I could capture that kind of stuff. You could say, well, how would you capture that? I mean, there's all sorts of things you could do with it. I could basically make a class that would inherit from, like, dictionary, for instance. I could say, well, let's inherit from dictionary, redefine the set item method to name, and then I'll just look it up. It's like if the name is in myself, and then, so yeah, if the name is in my, I have to think about this. Okay, so I'm going to basically look it up, say if I already have the name in myself, then what I'm going to do is basically pull out the value. So I'm going to say, okay, let's pull out the value here. Pulling it out, if it's not a list, I'm going to turn it into a list, and then I'm just going to append. Actually, I've screwed this up because I don't have that value there. Okay, so okay, I'm going to have to fix this in a second here. Okay, so let me fix this real quick. So hopefully people see what I screwed up there. It's I forgot to put in the value there. So. Yeah, I've got this completely messed. I think we're doing okay on time though. So. Hey, what? Val is the thing that was being pulled out there. It's it's not good style here, but. Okay, so I might be able to do something like that, and then I could say, well, okay, I'm going to make like a like a meta class that has that prepare method on there. Actually, I believe it just takes like the class name. Let's just try that and see what happens. And then what you could do is you could say things like, okay, well, this is my class spam or meta class. You're sort of getting an idea of how what sort of horrible evil would be possible here, where it's like you're going to have a bar method where x is int. Let's just see what happens there. Okay, well. Yeah. I blew it. Okay. Well, I don't know whether I'm going to keep hacking on that, but you get the idea where it's like, you could start collecting all these methods basically into a list, and then you could have some meta class basically pulling those together and doing multiple dispatch or overloading or something like that. I don't know whether I would recommend that. I'd probably not recommend that. I mean, I've actually kind of experimented with that, and it's almost too weird to work with. But that is sort of uncharted territory with annotations. I'm actually sort of wondering whether function annotations are almost like an aborted idea in the Python world. Does anybody know, is anybody using them for anything? It's,
There's some usual ways to type checking. So if you're actually going to do one of those things instead of actually showing me, oh yeah, I've got, I have to call these things to say it's instructor way. You encode it somehow into the Metaclasses pulls them off.
yeah, the question, yeah, it's a normal way. I think my fear, my fear with the annotation stuff is that they don't compose well between like libraries. Like if you're using some code that uses annotations for some purpose, you can't mix it with any other library that uses annotations for a different purpose. Because there's no way to have like multiple annotations on there in an easy way. And that's and I think that's definitely a problem.
Couldn't you solve that with Metaclasses?
Yeah, maybe, yeah.
The behavior, the contract-driven development or behavior by contract. Function annotation seems to place themselves well for that kind of program.
Yeah, the comment is that, maybe for like designed by contract stuff, you could do annotations. I don't know though, because I think couldn't you do like a decorator like this? Couldn't you do couldn't you do something like type assert int def add like xy like that? I mean, it's a slightly different formulation of it, but I think most of the uses of I think almost all the uses of function annotations could probably be replaced by decorators. If you were concerned about like kind of composing them and stuff.
Well, function annotations were explicitly put in without a They were explicitly put in saying, people have been wanting to play with type checking, this, that, the other thing. If we put this in, they have a framework to play with it. And we don't know what's going to work.
Yeah, the comment is they were put in without a purpose. I would actually slightly disagree with that. It turns out this is a bit of history. I've been going to Python conferences for a while, and I know sort of around I'd say 1999, maybe around 2000, there was actually kind of an interest in the Python world about the concept of optional static typing. There's a whole bunch of ideas sort of thrown around. The idea was, I wonder if we could put optional static types into the language somehow. Maybe like this. And then if you had that, could you do type inference across your source code? Could you take the static types and then propagate them through the source code and do maybe some optimization from it or things like that? So that there was actually some active discussion about that in the Python world. Could you have optional static types? It was kind of never really resolved because if you're doing type inference, one of the things that's tricky about that is it tends to be like a virus in your program, right? It starts all these types start to propagate, and it was never clear how you were going to get this optional thing to work. It's are you going to have optionally typed stuff mixing with partially typed things? And I just don't think it went. I don't think it went very far. And actually, my impression is that some of the things like PyPy ended up going in a different direction. It's like PyPy is looking at doing just-in-time compilation. They're analyzing your code to make it run fast, but they're not doing it through this idea of having an explicit specifier saying the type. So I don't know. I think that's where it came from. Honestly, is that? Do you have a thought on that, Mike?
I have a question about this one. You use two bar methods, but the method names are from the dictionary. Never went to like the last one.
Oh, the thing that I was trying to do here, I kind of screwed it up, is that I was actually trying to substitute my own dictionary under the covers where the set item method would basically check to see whether something was already defined. Yeah, what I was trying to do is basically collect all the duplicate definitions into a list. And then what I would end up doing with that list or something afterwards is basically processing it through a metaclass or something. I would have some piece of the code that would look at that and say, oh, there's multiple definitions for this.
And that would stop the second def from completely overriding the first def.
Yeah, right. Just the fact that you're collecting them would, right. So yeah, there are some interesting things there. Some other uncharted territory things are the use of non-local variables in closures and stuff. There's some pretty unusual things with that. Actually, Raymond Henninger has this really interesting recipe on the active state site where he basically lets you define, almost look like class definitions, but entirely using functions. You make like a function that you have like a whole bunch of inner methods, and then using non-local variables, it sort of creates instances and looks like classes. Very sort of intriguing code. There's also a variety of things like obviously like context managers. There's some weird thing, we didn't talk about that. To make the PyPy guys happy, you could start getting into things like frame hacking. That's probably a really bad idea. That basically modifying things like stack frames. Some other things that are kind of interesting is Python has the ability to parse its own source code. I don't know if you've messed around with that, but there's like the AST module where you could write out some code like, let's say you had some code fragment like that. You could actually do like an AST parse on that. Okay, basically parsing that, and it would actually turn into, I think there's like a AST, like there's a utility method dump that would do that. It'll actually take the source code down into sort of like a structure, sort of describing it. You could write tools that go into that and like walk through the source code and do like tree rewriting of the source code. You do analysis of the source code. Like one potential possibility is you could use that. Like here's a theory. Like I could like in this descriptor code that I did with all the execs. Okay, this set code thing that I was messing around with here. Maybe instead what I could do is take like the AST module, pull off the source code for a properly written set method, go in there, analyze it, maybe find like the super calls, and then take them out and then like rewrite the method. I mean, I don't know, in theory it's possible.
Like, can you go from an AST method?
Oh yeah. If you want to go back, if you want to take an AST and you take it to code, you just basically compile it. Oh, you need like a file name, so. And you also need it's been a while since you've used the compile function. Okay, so, but yeah, you can just compile like an AST and then take it down. So, variety of sort of crazy things. Now, as far as like kind of some final comments, okay, we've done all this sort of nutty stuff. It's like, should you do any of this stuff? I don't think this metaprogramming stuff is what I would use for like normal coding. I don't know what normal means, but if I'm just writing some script to process a log file or something, I'm not gonna do this. Framework code, library code, maybe a different story. I mean, you're probably using a lot of frameworks already that are doing stuff like this, but you don't realize it. Right now, there's a lot of activity, for instance, in like the science community with doing some of this metaprogramming stuff. If you look at things like the Numba project, where it's like, you decorate Python functions and it's like turning that into LLVM code, runs super fast. I mean, that's some really advanced stuff. There's some really neat stuff that you can do with that. So I think with that, I mean, we're basically out of time. We have like 5 minutes left. That's essentially the end of it. So I'd just like to thank everybody for coming. I hope you learned a few things. The Python cookbook coming out has all sorts of Python 3 stuff in there. Just a little bit about that book. That's basically, it's a ground up, clean rewrite of the Python cookbook, going from the perspective of, given a problem, how would you solve it in the most modern way possible in Python 3.3? It has a very interesting sort of spin on it. So look for that in May. And that's basically it. I can answer a few more questions if people have. It's a question there.
Just a quick comment. Since you showed code generation today, I'm not ashamed to share with the colleagues here that there is another interesting hook that's old in Python, and that's the coding. The coding, we start with the coding comments.
Oh, yeah. Okay, I think
That actually can be used to pre-process the whole code. So I have a little thought experiment here in which I can actually interpret Python code written with Portuguese language keywords, like instead of while, enquanto, instead of for, para.
Yeah. So the comment is about the source code. I forget the format for that. It's like a weird like. Do you remember what it is? There's like a thing you can put in your source code at the top, like.
When all asking source code if I can do it, right? So you're forced to do that.
Yeah, it's something sort of like that.
Yeah, but the thing is, it's hash.
Hash.
Yeah, and, yeah. So actually, it can be simpler than that. There's a way that does that. But the syntax is hashtag. The minimal syntax is hashtag space coding colon. No, just.
Well, okay, yeah, I know what you're saying. There's basically like this encoding thing that you could like, you can put at the top of like a source file and then.
The thing is, the name after the equal sign there is just a random encoding thing that you write.
Yeah. Okay.
Actually, we write all the source code while you're reading it line by line.
Okay. Yeah. Custom encoding. Yeah. Okay. That's a very diabolical. Yeah. Okay. I can see that. But if you're sort of wondering, okay, what is he talking about exactly? Essentially, you could put this thing in your source code and have your file processed through a custom encoder. It's kind of like, I guess you would say it's like source code rewriting through sort of a Unicode encoding hack. Yeah, I haven't really explored that, but yeah, I could. Okay. Interesting. Yeah. Comment here.
So how often does one set of people's metacode stuff sort of stomp on somebody else's?
Oh yeah, question, how often does somebody else's metaclass code stomp on somebody else's? I don't know whether I have an answer to that, except that I do know that horrible, horrible things happen if you ever mix like multiple classes originating from two different metaclasses together. Actually, I might be able to do that here. Like if you had like this positive integer class, let me. Okay, this was. Positive. Was it pos integer or positive? I think it was positive integer. So let's say you had some class like that, and then you decided for some reason that, I don't know, do you guys know about the ABC module? The like abstract base class module? I mean, you could have, this is sort of weird uncharted territory here, where you could say, well, okay, I'm gonna have some class that inherits from that. And then what if for some reason you decided you wanted to inherit from like positive integer and A? You'll start to get like just crazy error messages. I mean, I don't even know whether I fully understand this error message. It's like, meta class conflict, derived classes, non-strict thing. It's kind of like, okay, the coffee is worn off and I'm just going to go home. At that point, but I mean that's definitely a danger. Like multiple libraries. I don't know whether they mix so well, but Mike has a question.
You showed code where the metaprogramming makes things much slower. Do you have examples where actually got faster? Like if you use decorators, you might move things just in the compile step, then you don't construct the right code, and you don't generate like dynamic functions, so things might get faster. Do you have any examples for this?
Yeah, the question, do I have any examples of making things faster? Not off the top of my head that I would throw in there.
Like if you can write, if you have a function, then the function definition will be executed every time you call the outer function. But if you rather use the decorator instead of this, then you do it only once. You don't have to generate a function again.
Yeah, I have to think about that. So I definitely want to post the other solution with the structure initialization thing too, though. Okay.
So what's neat about the way you did it is that you could actually just have an option deciding whether to do all the checks or just to compile the code without doing checks. So if you're using this like in a web app, sanitize the user input, you need the checks. But if you're just using it in an in-house application, you can run it a few times, and if it works pretty well, then you can disable the checks and get this feedback.
Yeah. Yeah, the comment is like if maybe you could run it with the checks for a while and then take away the checks at some other point. Definitely. I mean, it's you can do any of that stuff in Metaclasses. Where it's like optionally turn the stuff off or on. Do it without changing the code. So, and then.
So, prepare takes class in the name and basis. Class makes sense. I was struck by the fact that we were just returning vanilla dictionaries of one kind or another. Do you think of any reason why you'd want to use name and basis in predefined compare?
Yeah, the question is, in that prepare method on a meta class, would you ever want to use the name and bases? Let me see if I find that code somewhere. Okay, so yeah, here. Yeah, I never ended up using them. I don't know. I'd have to think about that. I mean, maybe you would use that in some way. I mean, one thing about the prepare method too is it can actually take extra arguments. You know, like you could have foo and bar sitting there. If you do that, they actually become like extra arguments that you can use in the class definition. Like you could say metaclass equals struct meta foo equals 23 or something like that. It becomes a little bit tricky to sort of manage that, but yeah, potentially you could have like the prepare takes extra arguments with the intent of doing more control over what's happening with class creation and so forth. All right, I think we have time for one more question, and then. All right, that's it. Well, thank you very much, and I don't know.